Welcome to Python for Absolute Beginners course. In this course, we will mainly focus on the hands-on approach of learning Python. I am Talha and I have been working as a computer programmer and a Python developer for the last 6 years for major companies like Jalvix, Cybervision International, and NetSol Technologies. Over the years, I have worked on tens of dozens of projects related to data science, machine learning, deep learning, robotics, and web development. And I am here to teach you all one of the most in-demand and the easiest programming language, which will play a significant role in the future tech development. The program is specifically designed for absolute beginners, or for the people who have never wrote a single line of code before in their entire lives. Existing programmers with very little programming experience can also follow the course to enrich their knowledge. And in the end, people who want to start their professional careers can also learn through this course. As the course is designed for beginners, the course deals with the very basics of Python programming. At the end of every chapter in the course, I have included a project related to what we will learn in that chapter, so that students can have a hands-on experience throughout their journey toward excellence in Python. At the end of this course, students will have the ability to continue their professional careers in data science, machine learning or deep learning, robotics and automation, desktop application development, web development, and blockchain development. In the first chapter, we will start by installing the required softwares and packages into our computer to get ahead with working using Python. So in this video, we're gonna gear up our computers for working with Python environment. We will go ahead and install the 3 packages or softwares that we need to work with Python. The first one is Python, the second one is Git Bash, and the third one is Visual Studio Code. So I'll just go ahead and open up my Google Chrome, and I'll search for python.org to open up Python's official website. I'll navigate to Downloads tab, and I'll look for the latest version of Python, which is in my case Python 3.8.2. I'll click on that and I'll navigate through the page until I find the table named as files, and in those files I'll look for Windows x86 64 executable installer, and then I'll click on that, and my Python package is being downloaded. After that, I'll just go ahead and look for download Git Bash, and I'll click on the very first link, and after that I'll click on the option according to my operating system. In my case it is Windows, and I'll click on that, and my Git Bash for Windows will be downloaded soon. After that, I'll just go ahead and search for Vscode, which is Visual Studio Code, and I'll click on the first link, and I'll click on download for Windows because I'm using Windows operating system. And that's it. That's how I have downloaded all the 3 packages of software that I need for Python. So this is Git Bash, this is Python, and this is Visual Studio Code. So first of all, I'll just go ahead and install my Python package inside my computer. I'll double click on it to open up the installer. And before installing this package, I'll just go ahead and check the box add Python 3.8 to path, because if you don't do it now, you will have to do it afterwards, which might bring some errors. So after that, just click on install now, and your Python package will be installed in your computer successfully. Go ahead and hit close, and after that I'll just install my Visual Studio Code in my computer. I'll click on next, I'll click on next again, and here I will go ahead and check the first three options, and I'll also make sure that add to path option is also checked. So I'll click next, and I'll hit install button to install Visual Studio Code inside my computer. So I'll uncheck the launch Visual Studio option here because I don't want to open up my Visual Studio Code right now. And after that, I'll click on finish and double click on Git Bash setup and click on next. Click on next again, and because I had Git Bash installed on my computer already, so that's why it's showing me this. Just ignore this and click on yes. And after that, just go ahead and click on additional icons so that you get an icon on your desktop. Here, just go ahead and navigate to use Visual Studio Code as Git's default editor. Select this option and click on next. And here, go to the third option, use Git and optional Unix tools for the command prompt. And click next, and after that you have to click next, 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 and that's how your Git Bash is going to be installed too. So that's how I have installed all of three packages or softwares in my computer, and I'll open up my Visual Studio Code to show you that how its interface looks like. This is my Visual Studio Code. This is the front page of the Visual Studio Code that we'll use, and after that I'll open up the Git Bash, and this is the terminal that I have installed named as Git Bash. And the third thing was the Python package, and I'll open up Python, and this is the Python shell that we'll use in our upcoming videos. Hello everyone, this is an update for how to integrate your Git Bash terminal with your Visual Studio Code. In 2021 they changed the procedure a bit, so I'm just here to help you guys to make things a bit easier. Now, first of all, you have to download the brand new and upgraded version of Git Bash, and for that you have to go to the official website of Git, and for that you have to enter the URL, which is gitscm.com/downloads. After that, you will just get to this website right here, and from here you have to select the operating system that you're working on, and in my case that is Windows. So what I'll do, I'll just go ahead and select this option and click on that. Now, as soon as I will click on this option, the new setup of the Git Bash software will be downloaded in my laptop. To save our time, I've already downloaded it in my Windows machine. So what we will do is just go to that folder where I have saved the setup, and I'll double click on that. Now, as you can see, this is the installation wizard. So what I will do, I'll just hit next, next, yes, next, next, and from this drop down menu I'll just go ahead and select this option, which is use Visual Studio Code as Git's default editor. Now after that I'll just again hit next, 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 all the way to the end, and after that I'll just hit install. Now it will take a couple of seconds in installing this Git Bash into my Windows machine. Now as you can see, we have successfully installed the Git Bash in our laptop. Now what I'll do, I'll just uncheck this box and I'll check this one, and after that I'll hit finish. So this is the Git Bash terminal that we have just installed in our laptop. Now our next task is to integrate this inside Visual Studio Code, and for that what we will do, we'll just go ahead and open up our Visual Studio Code. Now for the sake of this video, I'm using the latest version of Visual Studio Code, and this is the home page of my Vscode. Here you can see we have PowerShell here instead of Git Bash, and we don't want that. We want our Git Bash integrated in our Vscode. So for that, I'll just go ahead and click on this little button right here, which is a drop down button, and here you can see an option which is a select default profile, and I'll click that, and here we have different options. The first one is PowerShell, second one is git bash, third one is command prompt, and the fourth one is Windows PowerShell. Now what I will do, I'll just go ahead and click on this git bash button. Now after that, what we will do, we'll just go ahead and close this Visual Studio Code and restart it. Now here you can see our PowerShell has been replaced by this bash terminal right here, and here you can see our terminal has also been changed, and this may seem a bit similar to this. So that means we have integrated this terminal inside of Visual Studio Code. So that is for this video. I just wanted to help you out guys who are finding it difficult to integrate or git bash with Visual Studio Code. Now using this method you can easily do that. In lecture 3 of chapter 1, we will discuss that how we can run our Python programs. In other words, we will see that how many ways there are in which we can execute our Python programs. Well, there are two ways to run a Python program. The first one is interactive way, and the second one is as a script. The interactive Python is good for a program of 2 to 4 lines of code. In other words, if you don't require a very long and complex functionality, and you don't have to write long sequence of logics, then interactive way might be good for you. But program of complex and long functionality requires a separate file consisting of number of lines of code. And after creating that separate file, we tell Python to run that file. We add .py at the end of the file name to indicate them as Python files. So I'll just go ahead and show you the practical demonstration of what I have just discussed here. I will open up my Vscode, and first I will discuss the interactive way. So for example, I only have to add 2 or more than 2 numbers, and then I want to print out the results that I get after adding them. So this program does not require large number of code lines. So I'll just go ahead and use the interactive way to perform this task. I'll type Python and I will assign the values to multiple variables. For example, x is equal to 20, y is equal to 30, and z is equal to 40. And what I want to do, I want to add all of these numbers with each other. Now what I want to do, I want to add all of these numbers. Suppose another variable, and I will store the value which I will get after adding all these numbers, which will be x plus y plus z. Now in the next step, I'll go ahead and try to print out the value of this variable. And this is the answer that I will get after adding all these 3 numbers. So this is the interactive way in which we can use our shell to execute very small number of lines of code. Now we will move ahead and we will create a separate file for Python which we can use as a script, which will describe the running of Python programs as a script. So what I'll do, I'll exit from here, and I will create a file named as script.py. Now this .py specifies the file as Python file. I'll hit enter, and a separate file named as script.py has been created here. We will just go ahead and write Python as a script. So I will use the same example that I have discussed in interactive way. I will assign the values to 3 different variables. And after that, I will suppose another variable named as sum, or it can also be used as add, is equal to, and I will add all of these 3 variables. And after that, I will just go ahead and print this variable. I will hit Ctrl plus S to save this file, and I will type here clear and hit enter to clear this terminal. And after that I will execute this file, which was named as script.py. Now this is the Python that we installed in our operating system, and through this command we are telling this Python to run this file, which is named as script.py. I will hit enter, and you can see that the result has been printed out here. So this is the way in which we can execute Python programs as a script. In the future lectures, we will discuss more complex and long Python programs which must be written as a script. Lecture 4 of Chapter 1 mainly deals with the number of ways in which we can structure our Python programs. There are 3 different ways in which we can structure our Python programs. The first one is sequential structure, which follows the sequential steps. The second one is conditional structure, which have to follow the conditional steps. And the third one is repeated structure, which have to follow repeated steps. Now the sequential steps means that sequence of steps to be done in order, which means that every step of the program will be done after another step until it reaches to the endpoint. Conditional steps may be skipped on the basis of the condition, and the group of steps to be repeated belongs to repeated steps, which means that there will be a block of code which will be repeated again and again until it satisfies a certain condition. Sometimes we store a set of steps to be used over and over again as needed at several places throughout the program, which will be discussed deeply in chapter number 4. Now looking deeply into the sequential steps. In sequential steps, the program flows from one step to another step. Now for example, in the first step, x will take an input. There will be a value that we will assign to the variable x. In the next step, that value which was stored in x will be multiplied by 2. And after that step, we will print out the result. This type of coding is called sequential scripting. Conditional steps mainly depend upon the condition that we define in them. Now for example, we have assigned a value of 6 in variable x. Now if x is less than 5, then it will print out lower. But if x will be greater than 5, it will skip the lower part and then it will print out the bigger. And after that, it will follow a sequential step and print out close. In our case, x is greater than 5 because we assigned the value of x as 6. So it will print out bigger, and after that it will print out close. In repeated steps, the program will run again and again until x becomes 0. And by x becoming 0, I mean to say that until it satisfies a certain condition that we defined in our program. For example, we have assigned the value of 5 to variable x. Until the value of x is greater than 0, it will follow the path on the right side. It will print out the value, and in the next step it will decrease the value by 1. And then it will again check the value. If the value is again greater than 0, it will again go to the right side and print out the value, and it will again minus 1 from it, and then it will again check the value whether it is greater than 0 or not. Now if the value is equals to or less than 0, then it will no longer go to the right side. Instead, it will follow the path of left side, and then it will print out close. These repeated steps are known as loops in Python. Lecture 5 of Chapter 1 deals with the variables and reserved words in Python. So variables are the words in which the values can be stored. For example, x is equal to 30. Here 30 is the value or constant that is stored in x. So x is called the variable, and this right here is an assignment statement. The next example is x is equal to x plus 2. Here equals shows the assignment, and plus is an operator, and the meaning of this statement is add 2 in the value of x and restore that value in the variable x, which means that after addition the value of x will be updated and the previous value will be overwritten. The next line is print x. This is a print function and it is commonly used to print the values that are stored in variables. In Python, we have several reserved words for different functionality. Those reserved words can be used as variable names. For example, false, class, return, none, if, for, true, def, and couple other more. In Python programming, all of these reserved words are used for specific tasks. For example, if is always used for conditional statements. We use for to write for loops. That's why these words cannot be used as variable names, because Python will not be able to differentiate these reserved words from variables. We will discuss the variables in detail in chapter number 2. Welcome to the lecture 1 of chapter number 2. In this lecture, we will discuss the differences between variables and constants. In other words, in this chapter, we are going to look deeper inside the variables. And to understand the concept of variables, we have to understand the difference between variables and constants. First of all, let's look at the constants. Fixed values such as numbers, letters, and strings are called constants. They are called constants because their values cannot change. There are two types of constants. The first one is numeric constants and the second one is string constants. Numeric constants can only contain numbers. These numbers can be of any type. They can contain decimal points in them, they can be in fraction, or they can be simply any real number. On the other hand, the string constants can only contain alphabetic characters or letters or words in them. For example, in string constant, we have written hello world. Now these are the alphabetic words that are stored as a constant. So this will be called string constant. Earlier we discussed that the constant are the values which cannot change. Variables are the words or names which contain or store those constants that we have discussed earlier. A variable is a named place in the memory where a programmer stored data and later retrieve the data using variable's name. Programmers can choose the name of the variable, which means that we can assign any name to the variable. Unlike constants, the value of the variable can be changed. For example, here I have taken a variable named as my variable, and I will assign a value of my name is John to that variable. Now after assigning that constant to my variable, I have allotted a place named as my variable in the memory of my computer, and in that memory I have stored a value which is my name is John. Now during writing a program I can recall that variable, and whenever I will recall that variable, that means I am calling its value, which is my name is John. Now we said that the values of variables can be changed. If you can see in the example, In the next line, I have assigned the different value, which is 94, to the same variable. And now if I will go ahead and try to print out that my variable, the answer will be 94 instead of my name is John. Because in the next line, I changed the value from my name is John to 94. And after doing that, my name is John is overwritten by 94. And now my variable has a value of 94 in it. In Python, reserved words can't be used for a variable name. Reserved words are the words that are already used in the Python library for specific tasks. That is why whenever we will use those reserved words as a variable name, the Python will not be able to differentiate whether this is a reserved word or a variable. That is why the best practice is to avoid using reserved words as variables. Some of the reserved words examples are given here. In this lecture, we are going to discuss the rules that we have to follow to name our variables. The very first rule that we have to follow is that our variable name must start with a letter or an underscore, which means that our variable name cannot start with a numeric character or a special character. The second rule is our variable name must consist of letters, numbers, and underscores. It should not have any special character at any point. The variable names are always case sensitive, which means that if you write a variable name in capital letters and you write the same variable name in small letters, both of these variable names will be different, and hence the corresponding variables will be different from each other. The good practice of writing variable names is given here. We can write our variable names just using letters and words. We can also write our variable names and use numeric characters at the middle or at the end of the variable name. And we can also add underscores in our variable name. We should never start our variable name with a numeric character or a special character. Also, we should never use a reserved word as a variable name. Now look here, all of these four variable names are different from each other. Because remember, we have discussed that variable names are always case sensitive. Here the first variable name is written in small letters, but the second variable name contains F in capitals, which make both of these variable names different from each other. Since we can choose the variable names, so there is always an opportunity of best practice. Try to give names to the variables which help us in remembering the data. And giving such variable names to our data is known as mnemonic variable names. Now variable names can get confused when writing longer scripts. For example, if you give random names to your constants and after that you go ahead and write longer scripts, at any point in your program you can get confused one variable with another. But if you use mnemonic variable name format, the chances of getting confused reduce to very low level. For example, look at here. In the first case, we have given the random names to our constants. But in the second case, to the string my name is John, we have assigned a variable name which is also named as name. And we have assigned 40, which is age of a person, as a variable name age. Now, no matter how long our script gets, we will always know that in the name variable we have stored the name of a person, and in the age variable we have stored his age. So this practice is called mnemonic variable name format. In this lecture, we are going to discuss assignment statements in Python. We will understand that what are assignment statements and how we can write these statements in Python program. But first of all, let's recall our variables. Variables are the words in which the values can be stored. For example, here the value of 30 is being assigned to the letter X. This whole statement is an assignment statement because here we are assigning the value to a variable. Now look at the next line. Here x is equal to x plus 2. On the right hand side, we have an expression which is x plus 2. And on the left hand side, we have a variable which is also x. And we are assigning the value of x plus 2 to the variable x. So this line shows assignment with expression. In the next line, we have print parenthesis x. This is the print function which is used to print the value of that variable x. Whenever we assign a value to a variable, we use an assignment sign which is equals. An assignment sign consists of an expression on the right hand side of the equals and a variable to store the result. For example, x plus 10 is an expression and on the left hand side of the equal is a variable. So whatever the result of x plus 10 will be, it is going to be stored in the variable x, which is on the left hand side of the equal. I am John is the string constant which will be stored in the variable name. And this expression 5.1 multiplied by x divided by 10 raised to power 2, all of this expression and its result is going to be stored in the variable x. Now let's look at the more example of assignment statements. Here on the left hand side, x is the variable to store the result of x plus 10. Name is a variable in which I am John is stored, and it can be recalled whenever we need them. Look at this example. Here y is equals to 5.1 multiplied by x divided by 10 raised to power 2. Here y is the variable which can also be referred as memory location, in which the answer of the whole expression, which is 1.275, is stored and can be recalled wherever we need it. Now let's suppose these two operations are written in the same program. In the first case, y has the result of 1.275, but in the second case, y has the result of 0.0829, which can also be referred as new value. This new value will be updated in the same variable y, and it will replace the old value, which is 1.275, because y is the variable and variable are the words which can change their value. Remember, everything on the right hand side of the equal is an expression. When we'll use Python, we will often have to deal with the mathematical expressions. And in order to solve those mathematical expressions, we will have to use numeric operators. So in this lecture, we are going to discuss the numeric operators in detail. Mathematical operators in computer language are a bit different than classical mathematical symbols. The purpose of those operators will be exactly the same, but the symbols through which we will show those operators will be different. For example, for addition, we will use plus, which is same as the classical mathematical symbol of addition. But for multiplication, we will use steric. For division, we will use slash. For power, we will use double steric. And for remainder, we will use percentage sign. Here are some of the examples of numeric expressions which are using numeric operators. In the first example, we are doing addition. In the first example, we are doing addition using plus operator. In the second example, we are doing multiplication by using steric operator. In the third example, we are doing division using slash operator. And in the fourth example, we are finding remainder using percentage operator. Here it is very important to understand the difference between division and remainder, which is also known as modulus. Now suppose you are dividing 16 over 2. When you will multiply 2 with 8, you get 16. And when you will subtract the 16 from 16, you get 0. That 0 is the answer of remainder, and that 8 is the answer of division. So that is the main difference between division and remainder. In this lecture, we are going to discuss the order of evaluation when we use numeric operators in our Python program. When we use string operators together, in other words, using multiple operators in a same line, then Python must know which one to do first. This is called operator precedence. For example, here we have a numerical expression in which multiple numeric operators are being used in a same line. So Python have to know that which part of the expression it has to solve first in order to get to the answer. This problem is solved by the order of evaluation. So the order of evaluation is as follows. In the first step, parentheses will be solved in the expression. After that, exponent will come next. After solving exponents, multiplication, division and remainder will be done. And after that, addition and subtraction will be solved. And all of these operations will be done from left to right. Always remember this order. Parentheses will be solved first. Exponent will be solved in the second place. Multiplication, division and remainder comes after solving the exponent. And in the end, addition and subtraction is done. For example, here we have an expression 2 plus 3 raised to power 5 by 5 minus 1. So in this expression, we have to solve the exponent at the first step, 3 raised to power 5, which is 243. After, as you know, multiplication or division or remainder comes. Here we have division, so the division will be done. 243 by 5, which comes as 48. After that, addition and subtraction is done. So start from the left. 2 plus 48 is 50. And 50 minus 1 is 49. And this is how Python solves our expressions which has multiple numeric operators in a same line. Now let's see the practical demonstration of order of evaluation. So we will open up our Python shell and I will assign the expression 3 raised to power 5 divided by 5 minus 1. And I will assign all of this expression to a variable called x, which means that the answer of this expression will be stored in the variable x. I'll go ahead and press enter. And after that, I will try to print out my variable x. And now you can see that it has printed out the answer of 49. Now let's see the step-by-step process to verify that the order we just studied was correct or not. So according to the order of evaluation, this expression term has to be solved first. So we'll go ahead and find the answer of this part, which is 243. In the next step, 243 should be divided by 5. So let's just divide 243 divided by 5. And the answer is 48. After that, 2 should be added into 48. And the answer is 50. And after that, 50 minus 1. And the answer is 49. So the order of evaluation is verified through this example. In this lecture, we are going to learn about comments in Python. We will discuss that what are comments and why do we use them in any programming language. First of all, let's just see how we can write a comment in a Python programming language. Hashtag is used to write a comment in Python programming. But why do we need comments? There are two main reasons behind writing comments in Python. The first one is describing what is going to happen in a sequence of code. And the second is turning off the line of code, maybe for debugging purposes. For example, here I have an assignment statement. X is equal to my name is Talha. And in front of that, there is a comment which states this line stores my name is Talha. Here this comment is actually describing what is going on in the line of code. And to see how we use these comments for debugging purposes, let's move towards the practical demonstration. Here is an example through which we can understand that how we can use these comments to describe our line of code. And also that how we can use these comments for debugging purposes. Now if you look at this line, you can see that it is starting from a hashtag. And unlike other lines, it is green. That is how we write comments in our Python program. Now this line is stating that value 45 is being assigned to variable x. Now if you look at this line, that's what is actually happening here. The value 45 is being assigned to a variable x. And if you look at this line, it is stating that this line prints the value of z. And that is what is actually happening here. Print function is used to print the value, and in the parentheses there is z. So obviously the print function is trying to print the value of z. So in this way we can use these comments to describe our line of code. Now for example, I go ahead and remove this hashtag to enable this line, and I save this file and I try to run it. You can see that instead of giving me the value of z, it actually showed me the error. So what if I move ahead here and put a hashtag here? As soon as I put a hash at the beginning of this line, it becomes green too. It means that this line has been converted to a comment, and because it is a comment, it is no longer enabled. Now what if I just go ahead and hit Ctrl+S to save this file again? And after that, what if I try to run this file again? You can see that this time it didn't show me any error. Instead, it gave me the answer, which is the answer of x plus y. So you can see that in this way, we can disable or turn off lines of code by using comments. And that is how we use these comments for debugging purposes. Up till this point, we have enough knowledge of Python to make a proper program. So in this lecture, we are going to make a very simple Python program. Sometimes we need to convert the user input to use for backend procedure. For example, what if I wanted to take the input from a user in runtime, and after that I want to add 1 into that number, and after that I want to print out the result of it. So adding 1 and printing out that result is the backend procedure. We use input function to take input from the user in runtime. But there's one thing that you always have to remember. The data which you take by using input function is always in string, which means that whatever value that will be stored in the variable x is a string. And hence 1 can be added in the string because 1 is an integer. So we have to convert that string into an integer. For that purpose, we use another function called int. Int function is used to convert the string data type into integer. And the correct syntax is writing the variable that we want to convert into the parentheses of int function. Now let's move to the practical demonstration of what we have just discussed here. So our task was that we have to take the input from a user in runtime. So I will suppose a variable in which the value will be stored is equal to, which is an assignment operator, and after that I will write input. This is the function that will take the input from user, and inside this parenthesis I will write enter your number. It is the string that the user is going to see whenever he runs the program. After that, this input function fetches the data that the user enters into the terminal, and after that, that data will be stored in this variable x. In the next step, we wanted to add 1 into our number. So let's suppose another variable y is equal to x plus 1, because x is the variable where the input from the user is stored. And after that, I want to print out this variable. Now I will save this file by Ctrl+S, and I will try to run this file using Python and name of this file. So this is the line that the user was going to see, and this time I am the user. So I'll just go ahead and type out 23 and hit enter. Now you can see that instead of giving me the answer, it showed me an error, because whatever value is stored in this x is in string, and we are adding an integer in that string. In order to solve this problem, we have to convert this string into an integer, and we will use a function called int, and we will write this variable into the parentheses of this function. Now I will again save this file, and I will again try to run this file. It is asking me for the number again. I will type out my number 23 and hit enter, and now you can see that it gave me the correct answer, which is 24. So congratulations, you just made your first proper Python program. In the future lectures, we are going to make complex and long functionality Python programs too. In the last section of this chapter, we have a Python program to make to strengthen our concepts of what we have learned so far. Write a program that takes number of kgs and price of rice per kg as an input from the user, and then calculates the cost of total number of kgs. So here we have to take two inputs from the user in runtime. The first one is number of kgs, and the second one is price of the rice per kg. After that, we have to do our calculations at the backend, which is also called backend procedure, and then we have to print out the result. So best of luck for this exercise. The question was, write a program that takes number of kgs and price of rice per kg as an input from the user, and then calculates the cost of total number of kgs. And I mentioned that here we have to take two inputs from the user. The first input is number of kgs, and the second input is price of rice per kg. So let's move ahead and solve this problem. Now first of all, I will go ahead and create a file named as exercise.py, because this relates to the exercise. I'll hit enter, and you can see that a file named as exercise.py has been created. So let's just write here exercise1. Now remember that I told you we have to take two inputs. So the first one can be stored in x, and the second one can be stored in y. To take the input, we have to use a function named as input, and in the parentheses we write a string that the user will see when it runs the program. So the first input will be enter the number of kgs. The second input will be enter the price per kg. So the first input will be stored in X and the second input will be stored in Y. After that, we have to calculate the cost of total kgs. So for that, I will suppose another variable and I will multiply number of kgs with cost per kg. That is how we can find the cost of total number of kgs. And after that, I have to move ahead and print out the value of z. But don't forget to convert your input strings into integers first, because this is an numeric operator and numerical operator only works for integers. So we will use int functions to convert our strings into integers. Now I will save this file by Ctrl+S and I will run this file using Python. I will hit enter. Now it is asking me number of kgs, so let's enter 3. Now it's asking me price per kg. Let's suppose the price is 40. Now it just gave me this answer here, 120, which we get by multiplying 3 with 40. Now let's just move ahead and make it more elegant. What we can do, we can write a string in the print, the cost of total number of kgs is, and after that we can write the variable in which the answer was stored. This is called concatenation. I'll hit Ctrl+S and I will rerun this file again. It is asking me for the number of kgs. I'll enter 4 and the price is 50, and the answer will be the cost of total number of kgs is 200, which we get by multiplying 50 with 4. Chapter 3 is all about conditional statements. But to understand that what those condition statements actually are, we need to understand the concept of comparison operators. In this lecture, we are going to move ahead and understand that what are comparison operators and how we can write them in Python. In Python, Boolean expressions ask a question and then return a yes or no answer, which is then used to control the flow of the program. This right here is known as comparison operator. Now the number on the right hand side of this operator is supposed to be bigger or larger than the number on the left hand side of this operator. Here we have a couple of other comparison operators, and on the right hand side we have the description corresponding to its comparison operator. For example, the first one we have less than operator. In the second position we have less than or equals to. In the next position we have equals to. Whenever we will write two equals together in Python, then that means that we are comparing two numbers and we are telling that the first number is equals to the other number. The next position we have greater than or equals to. In the next position we have greater than, and in the last we have not equals to. In future lectures, we will use all these operators in our examples to understand the use of these comparison operators. There is one thing that you need to understand is whenever we will use single equals, then that will mean that we are assigning a value to a variable. There's a slight difference between one equal and two equals writing together. The one equal will be used for assignment, but two equals written together will be used to compare two numbers. Here we have an example in which we will write conditional statements. We will use comparison operators and then we will write the blocks of code for the corresponding condition. Now at the very start, we are assigning the value of 6 to the variable x, and in the next line we are asking Python to check if x is less than 5. So here we are comparing our number 5 with our x, which has the value of 6. Now if x is smaller than 5, it will go ahead and print lower. But as you can know that the value of 6 is greater than 5, so it will not print out the lower part. Instead, it will move ahead to the next condition, which is defined as else if x is greater than 5. And if that's true, then go ahead and print bigger. And after that, get out of that conditional statement and then print close. So here we have used a Boolean expression to control the flow of our program. For the first part of the conditional step, the answer was no. So instead of printing lower, we moved to the other way, which was checking other condition. And when the second pass was true, then instead of checking any other condition, we move ahead and print it out bigger in our result. So here you can see different operators, and you can see what they are used for. Now x is equal to 5. Here equals is written single time. So this means that 5 is being assigned to the variable x. But in the next line, x is equals to 5, because here we have two equals together. In the next line, we have x is greater than 5, and then we have x is greater than and equals to 5, which means that the value of x starts from 5 and go all the way up. In the next line, we have x is less than 6. Here you can notice that the number on the right hand side of the comparison operator is the bigger number, and the number written on the corner side of the comparison operator is a smaller number, which means that the value of x is less than 6. And the same will be followed by the next condition, which is x is less than and equals to 7. In order to write the actual code for conditional statements, we have to understand the syntax of it. The concept of indentation in Python is really very important, because the slightest error in the indentations can lead up to very major problems, which might end up stopping the flow of the program. To understand the concept of indentation, I have taken the liberty of writing this very small example of conditional statements. In the first line, I have defined a condition using a comparison operator, which is x is less than and equals to 5, and at the end of this condition, I have added a colon. Now, as soon as I will hit the enter after that colon, the Python by default will add 4 spaces before the next line. As you can see that I have highlighted these 4 spaces using different colors. Now these spaces are known as indentations. In Python, we don't use any curly brackets to define the body of our condition or a loop. Instead, we go ahead and use these spaces to define the body of a certain condition. So right now, in this case, these 2 lines are the body of the first condition. And after these 2 lines, I have defined another condition, which is x is not equal to 10, and I have again added a colon at the end. Now as soon as I will hit the enter again, the Python will add spaces by default again. Whenever you add a colon in the statement, whether it is a loop or it is a conditional statement, the next line after that colon will have a certain amount of spaces before it. Those spaces are known as indentations. Here I have mentioned all the components of this program by using different colors. Orange color shows the condition, green color and the spaces are shown by indentations. The red color shows the body or the block of the if statement, and the gray color is reduced indentation, which means that this statement at the end is not the part of the previous condition, because in order to make it the part of the previous condition, I had to add spaces. But in this line, there is no space before the print, so it doesn't make it a body of the previous if condition. So this is known as reduced indentations, which also means that outside the if statement. Now there are multiple ways of using conditions. We can also use these conditions for one-way decisions, or we can also use these conditions for nested decisions. We will go ahead and see the video demonstration of what we have discussed here. So here we have an example in which we have these two conditional statements, and both of these conditions have the corresponding bodies for them, and this at the end we have a separate line. Now we will go ahead and understand that how Python actually differentiates between the body of the if condition and the statements that does not belong to any condition. So in the first line, I have defined a condition here, which is x is less than and equals to 5. Now if this condition is satisfied, the Python code enters to the body of this program and prints out these two lines. But you can notice that after I have added this colon, in the next line, if I go ahead and select this space, you can see that here we have 4 dots, 1, 2, 3 and 4, which means that here Python has added 4 spaces before this line. These 4 spaces are known as indentations. Now after printing out this second line, the body of the first condition has been finished. The Python will exit this condition. Now for example, if this condition was not satisfied, the Python would have moved ahead to the second condition, which is x is not equals to 10. And again, after the colon, the Python has added these 4 spaces to define that the next 2 lines is the body of this condition. After entering this condition, the body will print out these 2 lines. Now for example, I go ahead and add another condition inside the first condition. So it would look like this. If x is less than 3, and you can see that this time the Python has added these 4 spaces in addition to the previous 4 spaces. And if we go ahead and write something here, this will be the body of this condition, and this condition is inside the body of this condition, which is the first condition. So that's how we structure our conditional statements in Python. And you can call this a child condition, and you can call this a parent condition, because this condition comes inside this condition. Now as soon as we enter to the next line here, you can see that there is no space before this line. It makes this condition a separate condition which is outside of this first condition, and the Python will work on the body of this condition independently. Now this structure right here is also known as nested conditions, because this first condition is present in the second condition, and you can call this as a nest of conditional statements. We have more conditional execution patterns, which means there are multiple types of patterns in which we can use our conditional statements. For example, in the first line, I have assigned a value of 4 to the variable x, and in the next line, I have defined a condition which shows x is less than 5. So for example, when this condition is satisfied, the program will move ahead into the body of this condition and print out small. And if this condition isn't satisfied, for example, the number that I assigned to the x was 6, which is greater than 5, then the first condition will be falsified and the program will look for another condition. So here we have this if-else structure in our conditional statements. If gives one way to run the program, and if that condition is not satisfied, the program moves in the other direction, which is else. So for example, the number that I had assigned to the x was 6. In that case, the first portion of the condition will be falsified, and program will look for another condition, which is else, and program will go ahead into the body of this else and print out large. After printing out that large, it will move ahead to the next statement, which is outside the previous condition structure. and print out all done. We will use this visual block to understand what is actually going on. So at the very start, we had assigned the value of 4 to the variable x. After that, we have defined a condition which is x is less than 5. Now if the condition is satisfied, the program will move to the right side and it will print out small, and after that it will print out all done. But if somehow the condition isn't satisfied, the program will move towards left side and it will print out large, and after that it will print out all done. So here you can see that the conditional structure, the if-else structure, is shown in this control flow diagram. Let's have a look on another execution pattern, which we can also call a multiple conditionalized execution pattern. Now at the very start, I have again assigned the value of 4 to the variable x, and in the next line I have defined a condition which is x is less than 5, and at the end of this condition I have added a colon, and at the next line there is a certain amount of spaces before our print statement, which is actually called indentation. Now if the first condition is satisfied, the program will go ahead and print out small, and after that it will ignore all other conditions and move to the next statement, which is outside this if-else condition structure, and print out all done. But consider the first condition isn't satisfied. So after checking the first condition, the program will look for another condition, which is defined as else if, which in other words mean that if the first condition isn't satisfied, then go ahead and look for another condition, which is x is less than 10. Now if this condition is satisfied, the program will print out medium, and after that it will ignore all the coming conditions and print out all done. Now if the second condition is also falsified, the program will look for another condition, and this process will go on until it finds an appropriate condition or an output. We will try to see that what is actually going on in this program using our control flow chart. Now at the very start, I have assigned a value of 4 to the variable x. In the next line, I have defined a condition which is x is less than 5. Now if this condition is satisfied, the program will move to the yes direction and print out small, and simply it will move ahead and print out all done, ignoring all the other conditions in the program. But if the first statement isn't satisfied, the program will move towards the no direction and it will look for another conditional statement. Now here the second conditional statement is x is less than 10. Now if this condition is satisfied, the program will again move towards the yes direction and print out medium, and after that all done will be printed out. But if for some reason the condition isn't satisfied, for example the number is greater than 10, then the program will move towards the no direction and look for another conditional statement. In the third step, it will look for another condition which is x is less than 20. Now if your number which is stored in x is less than 20, then the program will move towards the yes direction and print out large, and after that it will ignore the next condition and print out all done. But if the condition isn't satisfied, the program will go towards no direction and print very large, and after that it will go ahead and print out all done. So this is how multi-way conditional patterns actually work in Python programming. Here we can also see the examples of indentation. We can see that the certain amount of spaces are being used to define the body of every condition. In addition to if-else structure in conditional statements, we also have another structure which is called try and except format. We will look deeper inside this try and except structure and will try to figure out what are the benefits that we can get from this structure. Now simply, if the code which is present in the body of the first condition, which is try, works, then except is skipped. But if the code of the body in try fails, then it ignores the try code and jumps to the except section. Now it seems exactly same as if-else structure, except it isn't. In if-else structure, Python looks for the condition and if the condition is satisfied, then the body of the condition is executed and it ignores every other condition in the program. In if-else structure, the Python judges the condition, but in try and except structure, the Python judges the body of the condition. If the code in the body of try works, then it ignores the other condition. But if the body of the first condition fails, then it has to execute the second condition, which is except. We will try to understand the use of try and except code by using an example. What if the program gets a string from the user as input instead of an integer? Now we all know that input function takes the input from the user in runtime and saves that input in a string format. And afterwards, we have to convert that string into integer, which you can see y is equal to int parenthesis x is doing that. But what if the user enters 5 in word instead of writing 5 in number? Then the second line, y is equal to int parenthesis x, will show error because the string cannot be converted into an integer. And that's when try and except structure comes into action. Now, for example, the input that the user entered was 112 in string. Now, what we will do, we will write a program using try and except conditions. First, we will write try, which is y is equal to int parenthesis x. In this line, we will try to convert our input into integer. Now, if this code works, the program will ignore except. But as we know that int function cannot convert string into integer, so this line of code will not work. And the program will move to the except section. And in that section, -1 will be assigned to the variable y. And after that, we will go ahead and print out the result is y, which is -1. Now on the right hand side, there is another example in which the user actually entered numbers. In this case, the code inside try will work and the string will be converted into integers. So the program will ignore the except section and print out the result is y, and the output will be the result is 112. That is how we can handle this string and integer problem gracefully using try and except structure. At the end of this section, we will move ahead and perform exercise to understand the try and except structure properly. So this is the exercise that we're going to perform, and the statement says that rewrite your pay computation program to give employees their pay based on the number of hours they worked if the rate per hour is 40. Use try and except structure to handle the non-numeric input gracefully. So what we have to do, we have to ask the user to enter their input in the runtime, and then we have to compute their pay, and then we have to print out their pay. But this time we have to use try and except structure, because what if the user give input using words instead of numerical values? In that case, we will have to use try and except structure to handle that non-numeric input gracefully. We have to solve this exercise using try and except structure. What we have to do, we have to ask our users to enter their input in runtime. They should enter their number of hours and they should enter the rate per hour, and then the program should calculate their pay and show their pay as a result. The program should also solve the problem of non-numeric inputs. So this is my Visual Studio Code where I will create a Python file and I will code my program. First of all, I'll move to the directory where I want to save my file, which is desktop, and I will move further to this folder which is called Udemy Python course, which I made certainly for the course, and inside of that folder I have to go to the chapter number 3 folder, and inside this chapter number 3 I have to go into 6th lecture, which is try except structure solution. And now we are in this folder right here, and here I will go ahead and create a file named as exercise_2.py. And you can see that a file named as exercise_.py has been created here. I will go ahead and clear out this terminal, and I will write a comment here, exercise 2 try and accept structure. Now, what we had to do, we had to ask our users to enter their inputs. So the first input that they should enter is the number of hours that they have worked for. And in the second input, they should enter the rate per hour. So we have to define two variables. The first one is x and the second one is y. In x variable, we will try to enter our number of hours. So we will write enter hours. This string will be shown to the user when the program will run, and this function input will take the input from the user in runtime and store that value in this variable x. We will do the same for y. We will use input function, and here this time we will ask for enter rate. Now we know that anything this input function will capture will be stored in string. So we have to convert the string into an integer. But what if the user has entered an input in words? So in order to solve this problem, we will use try and accept structure. Here you can see that I have written my condition try, and at the end I have added a colon, and as soon as I will hit the enter, a certain number of spaces will be entered in the next line. Here I will try to convert my string value, which is stored in x, into an integer. So I will write int x. This function int will convert this string into integer, and I will try to store this integer value into another variable which is called z. And I will do the same for y, int y. Now if this code works and both of the values are converted into integers from string, then I will simply just go ahead and define another variable, and I can calculate the pay by multiplying the number of hours with rate, which is d. Initially we stored number of hours in x and rate in y, but after converting this string into an integer, we stored the value into z and we stored the value of y into d. So in order to calculate our pay, we have to multiply z with d. And after that, I can just go ahead and print out the value pay, and here I will write the variable. Now let's just go ahead and define the second part of the condition, which is accept. I will write accept and add a colon at the end, and after that I will hit enter. And here I will just go ahead and I will write z is equal to -1 and d is equal to -1. And after that I will print out a string which is error, only numeric values can be added. Now let's just see how this code will actually work. First of all, the Python will try to run this program. It will try to convert the value of x from string into integer, and it will also try to convert the value of y from string to integer. And if that works, it will multiply both of these variables to calculate pay. And in the next line, it will print out the pay for users to see it. But if for some reason all of this code doesn't work out, what if the user entered the input in words instead of in numbers? Then these two lines will not run. In that case, the program will skip this part and then it will jump to the except portion. And if the values are not converted into integers, then the z will be equal to -1 and d will also be equal to -1. In that case, the program will print out error, only numeric values can be added. So we will just go ahead and save this file and we will try to run this file using Python. I will hit enter and it is asking me to enter the number of hours. For example, I worked for 23 hours. And in the next step, it is asking me for the rate per hour. For example, the rate is 2. So in the next line, it is showing me pay, which is 46. Now, what if I rerun this program again? I enter my number of hours as 23. And this time, I enter the rate 2, which is in words. And when I will hit enter, it is showing me that error, only numeric values can be added. So this is how we can use our try and except structure to handle non-numeric values gracefully. Chapter 4 mainly deals with the functions in Python. We will have an overview that what are functions and how we can use them in our Python programming. First of all, we have to understand that how many types of the function there are in Python. Well, there are two kinds of functions in Python programming. The first one is built-in functions and the second one is functions that we define ourselves. Now, built-in functions are the functions that are given as a part of Python through its libraries. For example, print, input, float, int, and so on and so forth. All these functions are already written inside of Python libraries, and we only have to call these functions to perform specific tasks. For example, print function printouts everything that is written inside the parentheses. An input function is used to grab the input from the user. Now let's come towards the second type of functions in Python. The functions that we define ourselves and then reuse them over and over again. For example, here I am defining a function named as test. To do that, I'll just have to write def, which is a reserved word to define a function. So I'll write def test parentheses and colon. And after that, I will hit enter. And Python will add certain amount of spaces before the next line. Those spaces are called indentations. Now everything that will be written next is the body of that function. Now for example, here print I am a function is the body of the function test. I'll just go ahead and write the remaining part of the program. I'll write x is equal to 4, which means that I'll assign the value of 4 to the variable x. In the next line, I will say the value of x plus 6 in the variable y. And in the next line, I'm just going ahead to print out the value of y. And after that, I'm recalling that function that I just defined previously, which is test. So when I will just go ahead and try to execute this program, the output will be like this. 10, I am a function. Now 10 is the answer of y, which was x plus 6. And after that, I just called the function that I defined previously, which was test. Now after calling that function, everything written inside that function will be executed, which is in our case is a single line of code, print I am a function. Now when this line will be executed, I am a function will be printed out in the output. Now that is how function actually work in a Python. Here print is a built-in function and test is the function that is defined by us. Now we'll see that how we can define a function. In Python, a function is a block of code which takes some input as an argument and do some computation and then returns a result. We define a function using def reserved word. As the function can be reused, we can call that function again and again at any part of the program. We call the function by using the function name and parentheses and an argument in an expression. For example, here def is used to define a function, and add is the name of that function, and a and b are the arguments. Now whenever you will call this function, it will take two variables, use them as an argument, and then add them, and then it will print out the value. We will just go ahead and see the video demonstration to understand functions in detail. In the video demonstration, we will go ahead and understand that how we can define a function and how we can execute that function in Python. So for that, we'll just go ahead and open up our Visual Studio Code. Now first of all, what I'll do, I'll just go ahead and define a function named as test. Here def is used to define this function, which has name of test. After this statement, I will put a colon at the end and I will hit enter. And as soon as I'll hit the enter, the Python will add certain amount of spaces by default. These spaces are called indentation. Now everything that I will write after these spaces will be the body of this function. Suppose I have written this line inside of this function test. So this line right here is the body of function test. Now after that, I'll just go ahead and write the remaining part of the program. For example, I take a variable x and I try to put a value of 4 inside it. After that, I take another variable and store the value of x plus 6 in it. Now the value of x was 4. So 4 plus 6 should be 10. In the next line, I will try to print out the value of y. Now after this line, what I am going to do is calling the function that I just defined previously. Now what will happen in the output, I will see the value of y, and after that I should see the value of everything that is inside the function test. So I'll just go ahead and save this file, and I'll try to execute this file using Python. You can see that in the result we can see 10, which is the value of y, and after that in the next line IAM function is printed out. Now this IAM function actually came from this test function, because in the test function we try to print out IAM function. So whenever you will call this function, everything inside this function will be executed. So let's just level up our use of functions. I'll comment out this to disable everything that I've written in this function, and in the next line I will define a new function named as add, and in the parentheses this time I will write elements. These elements are known as arguments of this function. At the end of this statement, I will put a colon and I will press enter. Now I have to define the body of this function. So for example, I'll take a variable c and I will put the value of a plus b in it, and then I will try to print out the value of c. The value of c is, and I'll write the variable name c. This part of the code will remain same, but here instead of calling test, I will call add. I will assign the arguments to this function too, which are x, y. Now when the program will call this function, it will also provide this function some values. The value of x will be stored in a, and the value of y will be stored in b. And after that, everything that is inside this function will be executed. So I'll just save this file and I will try to execute this file. Now you can see that in the first line we have 10, which is the value of y. And after that we called our function add, which was supposed to add these two values. The value of x is 4 and the value of y is 10. So 4 plus 10 should be 14. And you can see that the value of c is 14. So that's how we can execute and define our functions in Python. Functions can also be used for data type conversions. We can use built-in functions to find and manipulate the type of data. For example, here I have assigned the value of 6 to a variable x. I can use a built-in function called type to find the data type of x. As soon as I will put the variable in the parentheses of this built-in function and hit enter, it will return the result as class int, which shows that the value of x is actually an integer. In the next example, I will store value of 7.0 in variable x, and after that I will go ahead and check the type of the data. Now as a result, it will return the class of float, because whenever you put a floating point in an integer, the integer becomes float. So that is why the class changed from int to float. In the third example, I will store a string in a variable. Now on checking the type of that variable, I will get the class string, which shows that the value of x is actually a string. We can use built-in functions for type conversions. For example, here I have stored a value of 6 in the variable x, but this time I have stored this value using inverted commas, which means that this is a string. Now on checking the type of the data, as a result I will receive the class name string. But I can change the data type of x using a function called int. Now I will put that x inside the int function, and after that I will find the type of the new variable y, and this time as a result I will get a class of int, because int function just changed the data type of x from string to integer. In the third example, I am using the exact same variable which has the value 6 as string, and this time I am putting that x inside a float function, and I will store the value of this float function in variable y. Now after finding the type of the y, I will get a class of float, because the float function has changed the data type of x from string to float. We are controlling the data type with built-in functions. If the string has numeric characters, for example, x is equal to 1, 2, 3, 4, 5, 6, 7, but all these numbers are written in inverted commas, so that makes them a string. Now if you will check the type of the data using type function, the type will be string. And in the next step, what I'll do, I will put that x in which I stored my numeric characters into an integer function. I will store the value of that integer into a new variable y, and this time I will find the type of this new variable y. And as a result, I will get the type as int, which means that we have converted our data type from string to integer using int function. But what if the string has non-numeric characters? For example, here I have stored this string I am a non-numeric string inside of variable x. Now on checking the data type, as a result I will receive the data type as string. But when I will go ahead and write that x variable inside integer function, this time I will receive a traceback error, because non-numeric characters cannot be converted into integers. And now we will move towards a video demonstration to understand that how we can manipulate the data type in our Python program. we are going to understand that how we can manipulate our data types and how we can change the data from one type to another. So for that, I'll just go ahead and let a variable x, and I will assign it a value of 45, which is an integer. In the next line, I will suppose another variable y, and I will assign it the value of data type of x. So type is a built-in function in Python library which is basically used to find the data type of variables like x. So everything that this function is going to retrieve will be stored in this new variable y. And in the next line, I will just go ahead and try to print out the value of y. I will save this file and I will try to run this program using Python. And you can see that here in the result I am getting class integer because I stored an integer in this variable x. So let's just move ahead and put a floating point in this integer. For example, I'll just go ahead and write 0.4. Now this right here is a floating number. So this time type function will again retrieve the data type of the variable x, and that data type will be stored in variable y. And through this line, that class will be printed out in the answer. So I'll save this file again and I will run this file again. And you can see that the class has been changed from integer to float, because this time our data had floating point in it. Now similarly, for example, I'll change my data from integer or float to a string. I am a string. I'll save this file again and I will execute this file again. You can see that the class has been changed from float to string, because the data that was inside x is a string. Now we will just go ahead and try to convert our data type from one type to another. I will comment out these lines of code to disable them, and I will suppose a variable x and I will assign it a value of 5. I will let another variable y, and I will use type functions to find the data type of x. I will again print out the variable y and I will run this file. And you can see that at this time it is showing me class as integer. This time I will comment out this line and I will suppose a variable y, and I will use float function and I will put x inside it. Now this float function is a built-in function in the Python library which converts the integers into floating numbers. And in the next line I will try to print out my value of y. I will save this file and I will execute this file. Now you can see that the number has been changed from 5 to 5.0. Now what I'll do, I'll suppose another variable f and I will use type function to find the type of variable y, because after changing x from integer to float we stored its value in y. So this time we have to check the data type of y, and here I will print out f. I will save the file and I will execute this file, and you can see that the class has been changed from integer to float. So that is how we can convert our data type from one type to another. So what I'll do, I'll comment out all these code again, and in the new example I will use a string and I will put numeric values inside it. I will use another variable and I will store the value of data type of x inside it, and I will print out the value of y. I will save this file and I will execute this file. You can see that right now it is showing me class as string. I will try to change the data type of this variable x. For that I will let another variable g, and I will use int function to change the data type from string to integer, and I will put x inside it because I want to change the data type of x. And after that I want to store the data type of g inside y, and after that I want to print that y. Now I will save this file and I will execute this file. Now you can see that the class has been changed from string to integer. But what if we use non-numeric characters inside a string? For example, I am a string. This line here does not contain any numeric value. So let's see that if this int function still changes the data type of variable x or not. We will save this file and we will execute this file. Here you can see that it just gave us a traceback error because non-numeric characters cannot be converted into integer. Now we will see deeper inside building our own functions. So we define a function using def word, and then we use the name of the function, and then we place parentheses after the name of the function, and inside those parentheses we write parameters. These parameters are absolutely optional. After that we indent the body of the function. In other words, we use a colon at the end of the function defining statement, and after that we use appropriate spaces. Now everything that we have done so far, this just created a function. It did not print out the results. So the example that we use, we have defined a function which is named as add, and it has two parameters. The first one is a and the second one is b. And in the body of that function, we are doing a process of adding both parameters and storing their value inside C. Now this is the body of the function, but it just do the processes. It does not execute the result at this point. A function does not execute itself. For example, I have assigned the value of 5 to the variable x. In the next line, I have tried to print out a word hello. And after that, I have defined a function called func. And in that function, I have tried to print out two lines. The first one is I am the body of the function, and the second one is I am a new string. And after that, I have tried to print out the value of x plus 2, which is supposed to be 7. Now, when I will go ahead and try to execute this program, the output will be as follows. It will show me hello and 7. Now, everything that I just wrote inside my function isn't printed in the output, which means that it only does the process, it doesn't execute the result. To print the result, we have to call that function again. Now for example, after writing print x plus 2, in the next line, I am going to recall that function that I just defined previously. Now after executing this file again, the output will be hello 7, and after that I am the body of the function, and after that I am a new string. Now the function's body is printed after the result of x plus 2, which is 7. Because we actually called that function there, which means that until you call your function again, the function will never be executed in the output. As we are seeing these functions in detail, we have to understand that why we use these arguments inside of our functions. An argument is a value that we pass to a function as its input whenever we call that function. We use these arguments so we can direct the function to do different kind of work when we call it at different times. We can put the arguments in the parentheses after the name of the function. For example, here input is a function and everything that is written inside the parentheses is an argument. Now we have to understand the difference between parameters and arguments. Now consider the parameters as the general location where the multiple arguments can be stored. That parameter provides these arguments and access to the body of the function. A parameter is a variable which we use in the function definition. In the other words, in the statement where we define our function, if you write a variable in the parentheses, then that variable is known as a parameter. On the other hand, whenever you call that function in a Python program, and during that calling, if you provide a value or a variable to that function, then that variable or value is known as an argument. Now that argument will then be stored into the parameter, and then the value that is stored inside the parameter will be used in the body of the function. For example, here we are using a variable lang as a parameter inside this function greet, and on the basis of that parameter, the flow of the body of the function is controlled. Now whenever we will call that function and we will assign a value to that function, for example, here in this line I have recalled that function by using its name, and in the parenthesis I have provided a value that is en. This en is known as an argument. Now this argument will then be stored in lang parameter, and then that parameter will be used inside the body of the function. That's how arguments and parameters collaborate with each other in order to execute our functions in Python programming. Whenever we work with functions in Python, we also have to deal with the return values that those functions provide us as a result. Often a function will take its argument, do some computation, and then return a value which will be used as the value of the function call in the calling expression. Now by calling expression, I mean that whenever I will recall that function using the name of that function later in the program. Here calling expression is shown in green color, and the return keyword is shown in orange color. Here I have defined a function, and in that function I have written a line, return hello. So whenever I will recall that function greet later in the program, the function will return the result hello. For example, I have written this line here. So in the place of greet, the function should return the result as hello. So the line that will be printed out should be hello John. You can see that the output is hello John because the result that was stored in that function will be returned using the return keyword. And the same goes for the second line. We can classify our functions into two different categories based on the return values. We can categorize these functions on the basis of these return values. The first category is a fruitful function. A fruitful function is the one that produces a result or return some value after executing the function. Whenever you write a return keyword at the end of your function, that return statement stops the function execution and then sends back the result of that function. For example, here you can see that I have written a couple lines of code. First of all, I have defined a function called greet, and then I have provided that function a parameter called lang. Inside that function, I have used multiple conditional statements, and whatever value that will be stored in that parameter will then be checked by these conditional statements, and the output will depend upon the value that will be stored in that lang. So after defining this function, I will go ahead and recall that function in the next line. Here you can see that I have recalled that function and I have given it an argument that is en. Now that argument will be stored in the parameter lang of the function, and then it will be checked by the conditional statements. As I have given an argument of en, so the first condition will not be satisfied and the function will move to the second conditional statement. You can see that this statement cannot be satisfied again. So after that, the function will move on the next condition, which is else, and when this condition will be satisfied, the function will return the result that is present in the body of that condition, which is hello. So as a result, the output will be hello John, and same goes for these two lines too. We can define more than one parameter in the function definition. We simply add more arguments when we call that function. In other words, if we are using multiple parameters, then whenever we will call that function, we will have to provide the same amount of arguments to that function too. For example, here I have defined a function named as add2, and in the parentheses I have provided two parameters, which is a and b. In the body of that function, I am moving ahead and adding those two parameters and saving their value in the added variable. And after that, in the next line, I am returning the value of that variable added. So later in the program, whenever I will recall that function, just like I have done here, I will provide arguments to that function, which in this case are 3 and 5. Now that 3 will be saved in A and that 5 will be saved in B. After that, both values will be added, which will give the value of 8, and that 8 will be stored in variable added. After that, the value of added will be returned in the output. So whenever I will try to print out the value of x, I will get an output of 8. All the computation that yielded the answer of 8 was done in the function add2. The second type of the functions are non-fruitful functions. When a function does not return a value, we call it a void function. On the other hand, the functions that return values are fruitful functions. This means void functions are not fruitful. In chapter number 5, we will look towards the loops in Python. We will try to understand that how we can define and use our loops in our Python programs and what are the benefits that we can get from them. Unlike conditional statements, in which we have to choose the direction or the flow of program, loops deals with the repeated steps. In other words, the loops perform iterations. And those iterations have iteration variables that change each time through a loop. For every different iteration, the value of the iteration variable will be changed. Often these iteration variables go through a sequence of numbers which are also known as arrays. For example, here I have supposed a variable n and I have tried to assign the value of 5 to that variable. In the next line, I am trying to define a loop statement. In this case, we are using a while loop. And after that, I am trying to define the condition for that loop. In other words, if this condition is satisfied, then the loop will be executed. And as soon as the condition is falsified, the loop will be ignored. Now in our case, n is greater than 0. The value of n is 5. And 5 is obviously greater than 0. In that case, the program will move into the body of the loop, and according to the first line, it will print out the value of n. And after that, it will move ahead and subtract 1 from the value of n. And the new value will be updated in the n variable. In the next step, the value of n is again checked whether it is greater or less than 0. Suppose the value of n is again greater than 0. Then the previous steps will again be repeated. The loop will print out the new value of n, and in the next step, 1 will again be subtracted from the new value of n. Now this newest value will again be updated in the variable n. And after that, it will again be checked whether the value is greater than 0 or not. And this way, these steps will be repeated over and over again until the value of n is equals or less than 0. Now suppose after some iterations, the value of n has become 0, which falsifies the condition. Now in that case, the loop will be terminated and the program will jump to the next statement, which is print done. You can see that in the output, for the first iteration, the number 5 has been printed out. But in the next iteration, the 5 has turned into 4 because we performed n-1 operation inside the loop. Now again, this 4 is greater than 0. So in the next iteration, 1 will again be subtracted from it, making it 3 from 4. And the same process will be performed again and again until the value of n becomes 0. And as soon as the value becomes 0, instead of continuing the process of that loop, the program will ignore that loop and print out done. There is another way of breaking out of a loop. The break statement ends the current loop and jumps to the statement immediately following the loop. In other words, suppose you have placed a break statement in the middle of your loop body. Now after executing that break statement, whatever that is after of that break statement will be ignored, and the program will jump to the statement which is outside the loop. It is like a loop test that can happen anywhere in the body of the loop. Here I have used again an example of while loop. In the body of that loop, I am trying to get an input from the user in runtime. And after getting that input, I will store that input in a variable called line. After that, I have defined a conditional statement in which I will check that whether the input is done or not. If the input is done, then the program should break this loop. And after that, the print line will be ignored and the program will jump to the print done, which is outside of the loop. Now let's look at the output of this program. In the first line, the program is actually asking us to enter your word. Now you can type any string you want other than done, and the program will print out the same string that you have typed in. But as soon as you type in done, the program gets into the conditional statement and breaks the loop, after which that done does not get printed out. Instead, the done which is outside the loop is printed out. And you can see that in this done we have an exclamation mark at the end. We can also finish an iteration with continue statement. The continue statement ends the current iteration and jumps to the top of the loop and start the next iteration. Here I have taken the same example of while loop that I previously used. But in this example, this time I have defined another conditional statement. In this conditional statement, I am trying to figure out the first character of the input, and I am trying to compare that character with hash. If the input starts with hash, then the program will proceed towards continue statement. If the input contains done, then the program will proceed towards break. And if all of these conditions are not satisfied, then the program will just go ahead and print out our input. Now let's just look at the output. In the first line, the program is actually asking us to enter your word. Here, for example, I have entered hello world, and the program has printed out the same hello world. But in the second time, I have typed in hash print. Now you can notice that the first character of this string is hash. As soon as the program sends this hash, it proceeds to the continue statement. So instead of printing out my input, the program breaks the loop and goes right back to the top of the loop. Now in the third example, I have typed in done. Now as soon as I type in done and hit enter, the condition written for done is satisfied and the program moves toward the break statement. Now just like continue statement, after the break statement, print line will not be executed. Instead, the program will get out of the loop and print done. Let's just see the video demonstration to understand the very basics of loops. Now first of all, we will see the use of break statement. I have used the same exact example that we discussed previously. In the first line, I am defining my loop, which is while loop. In the body of that loop, in the first line, I am trying to take the input from the user in runtime and then storing that input in the variable called line. Now in the next line, I am defining a conditional statement in which I am trying to figure out that whether the input contains string done or not. Now if the input contains done, then the loop should break itself, and instead of printing out this line, the program should jump on this line. Now to differentiate these both done from each other, I will enter these exclamation marks. So what I will do, I will save this program and I will try to execute it using Python. You can see that here it is asking us to enter a word. Let's suppose I will enter hello world, and you can see that it printed out the same string that I just typed in, and after that it is again asking me to enter the input. So for the clarification purposes, I will enter another string. For example, my name is John Doe, and I will hit enter, and you can see that the program again printed out the same string. This time I will go ahead and type out done, and I will hit enter, and you can see that instead of printing out this done, the program moved to the next string and printed out done exclamation marks. Now you can clearly understand that after I inserted done value in the input function, the program ignored this line, and instead of that it got out of that loop and printed out this line. So that's how this break statement actually works. Now we will understand the use of continue statement with the practical demonstration, of course. Now this is the exact same example that we discussed previously, but this is the extra part of the program that I just entered right now. So in this line right here, I have tried to define another conditional statement in which I'm trying to figure out the first character of the input, whether that first character is hash or not. So if this statement is satisfied and the first character of the input is hash, then the program will proceed towards continue, and after that it should proceed towards this print line. And if the second condition is satisfied, which is if the input is done, then the program should proceed towards this break statement, and after that it should move towards this line. But we have seen this previously, that instead of printing out this line, the program jumps to the outside of the loop and print this line. So what I'll do, I will save this program using Ctrl+S, and I will try to run this program again. The program is asking me to enter my input. So for example, I will type in hello world, and I will hit enter, and you can see that the program has printed out the same string that I just typed in. In the next step, what I'll do, I will write hash hello world. Now the first character of my input is hash. I will hit enter. So instead of printing out anything, the program just moved back to the top of the loop, which is this first line, right? So that's how this continue statement actually works. So what I'll do, I will just move ahead and type out done this time, and I will just go ahead and change this output here, and I will write finish instead of done, so we can differentiate between this output and this output. Okay, so I will execute. We had to save this file again and then execute the file. I will just go ahead and execute the same file, and this time I will type in done. I will hit enter, and you can see that the program did not bother to print out the string that I just typed in. Instead, it moved outside that loop and printed out this finish. So that is how the continue and the break statements in loops actually do work. We will discuss the difference between the working of continue and break statement, so that we can understand and differentiate the outcome procedure of both statements. So whenever the continue statement is executed, everything that is after that statement inside the loop will be ignored, and the program will jump at the very top of the loop, which in this case is this line. But on the other hand, whenever the break statement gets executed, everything that is after that statement inside the loop will also get ignored. But this time, instead of going at the top of the loop, the program jumps out of the loop and executes the very first line of code that comes after that loop. In other words, continue statement asks the program to go to the start of the loop, and the break statement asks the program to leave the loop and execute whatever line of code that we have after that loop. In this lecture, we are going to have a quick overview about indefinite loops. The loops that we discussed in the previous lectures are further classified into two different types. The first type is indefinite loops, and the second one is the definite loops. While loops are called indefinite loops because they keep going until a logical condition becomes false. Now, if you can remember that, in the previous lecture, when we used an example of a while loop, we had to define a condition for that. Until that condition was true, the loop performed all the iterations. But as soon as that condition was falsified, the loop was terminated and the program jumped right at the end of the code. So that is the reason that why we call these while loops indefinite loops. The loops we used were pretty easy, and it was relatively simple to examine that whether those loops will terminate or not depending upon the condition that we defined in those loops. But sometimes it is a little harder to be sure that if a loop will be terminated or not. In that case, our break and continue statements come into action. Here I am using the exact same example that I discussed in the previous lecture. You can see that in this line I have started a loop which is a while loop, and after that I have defined a condition for that which is n is greater than 0. So until this condition is satisfied, everything that is written inside the body of this loop will be executed over and over again. But as soon as this condition is falsified, everything that is written inside the loop will be ignored and the loop will be terminated. And the program will jump right at the end of the code and execute this last line of the code, which is print done. So these are indefinite loops. Now is the time to go for the examples and understand that how these loops actually work. In this lecture, we will move ahead and perform several examples to understand the working of the loops. We will go through simple examples which will deal with the mechanism of loops, and even though these examples will be simple, the pattern applies to all kinds of loops. In other words, after performing these examples, you will understand the basic concept of loops, and that pattern and concept can be applied for complex and very long functionality programs too. Now, for loops are used to find or do something for each entry separately, and after that they update a variable, and that is called looping through a set. So here we have an example. In the first line we want to print before, just to give it a starting point. There is no purpose of this line whatsoever. We are just defining a starting point for the program, and after that I have defined a for loop. After the for, I have written thing, and this thing here is an iteration variable, and you can remember that we can give any name to our variables. We can also write I, we can also write number, we can also write thing, or any other name you want to give to the variable. You can do that. And after the in operator, you want to write your set of data, which in this case is 9, 41, 12, 3, 74 and 13. Now in the body of this for loop, what I want to do is I want to print out every element that is present in the above set of data. And after going through the entire process of the loop, I want to print out the end as the finishing point of the program. So when we will execute this program, in the very first line, you can see that the before has been printed out. And after that, for loop is being executed. Now this loop will go through all the elements inside the set of data, and it will start from the very first element, which is 9. So in the first iteration, it will print out 9. And in the next iteration, it will move towards the second element, which is 41. And that process will be repeated again and again until the last element, which is 13. Now after the 13, we don't have any element inside the set of data. So that for loop will be terminated, and the last line, print end, will be executed. You can see that at the end of the output, end has been printed out. Earlier we said that For loops can be used to find elements in a set of data. So what if we want to use this for structure for finding the largest number present in the set of data? For that, this loop will obviously go through all the elements one by one, and then the loop will compare all those elements with each other to see that which one is the largest one. Now the loop will go through all the elements. It will start from 9, 41, 12 all the way to 13. We will define a reference number and we will say that our first element is the reference number. If the new coming number is larger than the reference number, then the value of reference number will be updated, and the process will be repeated again and again until the very last element of the set of data. In this way, we can find out that which one is the largest number present inside the array of numbers. We will go ahead and perform this program inside of our Visual Studio Code to understand that how we can write our loop programs inside of our Python programming. Now we will see that how these loops actually work, and for the first time we will see for loop in action. And first of all, I will suppose a variable and I will assign a set of data to that variable. Let's suppose the data is 1, 34, 56, 67, 8 and 0. Now what I want to do, I want to use for loop to find out which one is the largest number present in this set of data. Right? For that, I will write for, and then I will write number. This is the variable that the for loop will use for the iterations. And after that, we will write in operator and then x. And after that, we want to place indentation and hit enter. So this statement right here is actually saying that look for each number in the variable x. So for loop will look for each number that is present inside the variable x, and it will do that one by one. So we want to find the largest number present inside our set of data. For that, we need a reference number. Consider this as a starting point with which we will compare our numbers to see that whether they are larger as compared to that reference number or not. So for that, I will just go ahead here and write reference number. This is a variable name and I will put 0 in it. So 0 is the smallest number which I am using as a starting point. Now what will I do? I will place a conditional statement here and I will ask to check whether the number that came from this set of data is greater than the reference number. If that's true, then update the value of reference number as the value of number. In other words, put the value of number which was greater than this reference number inside this reference number. It will update the value of reference number from 0 to the new number. After that, I will get out of this if body, and after that I will get out of this for body. And here I will write print reference number. I will save this file and I will execute this program. You can see that it gave me the biggest number, which is 67. And you can see that in this set of data, the biggest number was 67. We can also write print reference number here to see the updation of reference number for each iteration. And I will write the largest number is, I will save this program and I will execute this program. And you can see that for the first iteration, it compared 0 with 1. And it saw that this new number 1 is greater than 0. So it updated the reference number value to 1 and printed out that value. And in the next iteration, it compared this 1 which was already present in the reference number to the next coming number, which was 34. And after comparing them, it understood that 34 was greater than 1. Then again went ahead and updated the value of reference number. And after that, it printed out that reference number, which is 34. In this way, the process is repeated until the last element of the set of data was iterated through. And at the end of this set of data, the for loop was terminated and the biggest value of the reference number was then transferred to the last line of code, which is print the largest number is reference number. In this lecture, we are going to move ahead and try to understand that what are loop operations. In other words, we will try to learn that what kind of operations we can perform inside of our loops. And we will learn all of that by using several examples. So as a first example, I'm going to discuss the counting in a loop. In other words, we will try to count the number of iterations that will be performed in a certain loop. So to count how many times we have executed a loop, we introduce a counter variable that starts at 0, which means that at the very beginning of the program, that counter variable will have a value of 0 in it. And then we will add 1 to it each time we will perform an iteration. So in the first line of this program, I have defined a variable by name of val. Now this variable is actually a counter variable which has value of 0. And after that, I have tried to print out before and then the value of val. So this line right here just plays the role of a starting point. In the next step, I'm going to define my loop, which is a for loop, and in that loop, number is the iteration variable. Now that iteration variable will have different values in different iterations. Here int is an operator which will help my iteration variable to look inside the set of data. Now in the body of this loop, in the first line, when the iteration variable looks for the first item in the set of data, then it will add 1 to the previous value of the val, which was initially 0. And the result of this operation will be updated into the same variable val. In the next line, it will print out the number of iteration corresponding to the number which is present inside the set of data. Now, for example, you can see that in the output, 1 has been printed out against 9 because 9 is the first entry inside this set of data. So that 9 will be printed out in the first iteration. That's why 1 has been written against 9. Now this whole process will be performed again and again until all of that data is covered through the loop. Now as soon as the last entry is processed through that loop, the for loop will be terminated and the program will jump to the last line, which is after val. Now at the end of this program, the value of val will be the number of iterations that has been already passed. So as the result, 6 will be printed out because there are 6 entries inside the set of data. So the loop iterated for 6 times. We can also perform summing inside the loop. Now this summing in a loop means that summing all the entries that are present inside the set of data. Now to add up all the values that we have inside the loop, we introduce a sum variable that starts at 0, just like we did with the counter variable in the previous slide. And then we add the value to the sum each time through the loop. In other words, inside every iteration, we will add the next value to the previous value. Here val is a sum variable which is starting from 0. And after that, I have printed before and the value of val just for the sake of defining my starting point. And after that, I have defined my loop, which is a for loop again, and number is the iteration variable. In is an operator that will help my iteration variable to look inside the set of data. Now in the body of the loop, what's going to happen is the value that is stored inside the iteration variable will be added into the value of val, which is initially 0. And the result of this operation will be updated in the same variable val. So for example, for the first iteration, the first entry of the data is 9. and the previous value of val was 0. So 0 plus 9, the answer should be 9. And you can see that in the output, 9 has been printed out against 9. Here the 9 which is in blue is the result of val which we got after adding both numbers. And the 9 in the red is actually the entry that is present inside the set of data. Now in the second iteration, the next entry will be added into the previous value of val, which is now 9. And we will get 9 plus 41 is equal to 50. So as a result, for the second iteration, 50 will be printed out against 41. And the same process will be performed again and again until the loop finishes its task. And after that, at the end, the total sum of all the entries will be printed out against after. So first of all, we will look ahead and try to make a program that will count the number of iterations inside a loop. For that, I have to define a variable, which is actually a counter variable, which starts from 0, and then it will add 1 in itself for each of the iteration that it will pass through. So suppose that variable is counter variable. You can use any name of the variable you want, because at the end of the day it is just a variable. So I will assign the value of 0 to that variable, and after that I will write a loop, and I will write an iteration variable. And again, you can use any name you want. You can write number, you can use any type of variable name that you want. So let's just move ahead and type in number, and then I will write in operator. And after that, I will write my set of data, which is 1, 2, 45, 67, 8, 34. I think this should be enough. And after that, I will type in colon and I will hit enter. And the Python will add a certain amount of spaces, which are also called indentations. And here I will define the body of this loop. So what I will do, I will write my counter variable name again, and I will add 1 into that variable each time this loop is executed. So this 1 will be added into the previous value of the counter, and that resulting value will be added into the counter variable. And after that, what I will do, I will try to print out the counter value for each of the iteration, and also the entry which will be stored in this iteration variable, right? So as the result of this line right here, the number of the iteration will be printed out, and along with that, the entry that is stored in the iteration variable for that particular iteration will also be printed out. And after that, I will get out of the body of this for loop, and I will try to print out number of iterations are. And here I will print out the value of this counter variable, which is actually storing the number of iterations. So I will type in counter underscore variable, and I will save this file. And after that, I will try to execute this file using Python. I will hit enter. And you can see that for the first iteration, the entry is 1, and for that entry, the number of iteration is also 1. And for the second iteration, the entry is 2, and hence the number of iteration is also 2. For the next iteration, the entry is 45. So here 3 is printed out as the number of iteration, and 45 is the entry that is being processed in that particular iteration. And at the end of this program, number of iterations are printed out, which are 6. You can see that here we have 6 entries here. So for loop will run 6 times, and the number of iterations will be 6. So that is how we can count the number of elements inside a set of data by actually counting the number of iterations of the for loop. In this video, we will try to make a program that will add all the entries that are present inside a set of data, which is also called an array. So for that, what I'll do, I will just go ahead and create a variable, which is a sum variable, and I will assign a value of 0 to that. Now, you can name anything to this variable. I just gave it the name of sum because it will be easier for me to remember that. And this variable starts from 0, which means that initially the value which is inside this variable is 0. And after each iteration, that value will be changed according to the data that we are going to process in our program, right? So let's just also go ahead and try to count the number of iterations of this program too. And for that, I will define another variable, which is a counter variable. Just like in the previous video, and I will assign a value of 0 to that variable. Now in the next step, I will define my for loop, and I will use my iteration variable as number, and I will write my in operator, and after that I will write my data, which is 1, 3, 56, 67, 90, and I think this should be enough. And after that, I will go ahead and type in a colon, and I will hit enter, and the Python will add indentation at the start of this line. And now I will just go ahead and type in the body of this loop. So first of all, what I will do, I will try to find the number of iterations, and for that I will write this counter variable, and I will try to update the value of this counter variable after each new iteration. So for that, what I'll do, I will write this variable again, and I will add 1 into it, just like we did in the previous lecture. So this line right here means that after each iteration, 1 will be added into the previous value of the counter, and that's how this variable will store the value of the current iteration. Now the main thing that we want to do in our program was to sum all the values inside the entry. For that, I will update the value of sum, and what I'll do, I will write sum, and I will add number in it. So we need to understand that what this line is actually doing. For the very first iteration, the value in the sum is 0 because we just defined that this value of sum should be 0. So for the first iteration, the value of this iteration variable, which will be 1, is going to be added in the value of sum, which is 0. So the answer that we will get from 0 plus 1 is equal to 1. That answer will be updated in this variable. And what I will do, I will go ahead and try to print out the value of the counter variable, and along with that I want to print out the value of sum. So this variable right here will print the number of iteration that is going on. What I will do, I will just go ahead and get out of this loop, and I will write the sum of all the entries is, and after that I will write sum, because at the end of this program, the result that we will get after adding all the entries of this array will be stored in this sum. So we will save this program, and after that we will try to execute this program. Now you can see that in the first iteration, the number that was stored in the iteration variable is 1. So this is the first entry of our array, and because this is the first entry, so the iteration will be the first. Now the second element in our array is 3. So for the second iteration, the answer of the sum variable should be 1 plus 3, which is 4. And you can see that here 4 has been printed out. And this process is being done in the second iteration. So along with that, 2 has been printed out. Similarly, 56 is the third entry of this array. So in the third iteration, the sum should contain the answer of adding all these 3 elements, which should be 60. So you can see that in the third iteration, 6 has been printed out along with the number of iteration, which is 3. So this process will be repeated again and again until all of this array is being processed. And at the end of this program, we will print out this line which states the sum of all the entries is, and after that we will print out the actual sum of all the entries that we got after doing our operation, which is 217, right? So what if we want to find the average? Finding the average. To find the average, we have to follow up this formula in which I have to sum all the entries that are present in the array, and then I want to divide that sum on the number of entries that array contains, right? So here number of entries can be shown by this counter variable, because the number of entries will be same as the counter which is counting the number of iterations. So what we will do, we will try to print out a string which states the average of all the numbers is, and after that what we will do, we will divide this sum by the number of elements which are stored in this variable. So we will just go ahead and write sum divided by counter variable, and we will save this program. We will again execute the program. Now you can see that after this line which shows the sum of all the entries, this new line has been printed out which states the average of all the numbers is 43.3. So that is how you can perform your operations inside of loops. In the chapter 6, we will go ahead and understand the data structure strategies inside a Python program. In other words, whenever we perform some coding, we have to structure our data in order to process that data inside of a program. So there are multiple ways in which we can structure our data. And that field that deals with the structure and the layout of the data inside of a Python program is called data structure. The very first structure that we are going to discuss is the string. And I hope that by now you have some sort of understanding that what the strings actually are. A string is a sequence of characters. Those characters can be numbers, they can also be words or letters, and they can also be special characters. But all those characters have to be written inside the inverted commas. Now, a string can also contain numbers, but it is a still string. And we all know that we can convert that numeric string into integer by using that int function. For example, here I have written a program. I have supposed a variable which is a string 1, and I have stored a value in that which is hello. Now this hello is the non-numeric string, and I have did the same with the second variable, and I have assigned the value of there in it. Now what I'm doing in the third line is actually called concatenation, which in other words is known as adding two strings together. And after adding these two strings together, the resulting string is being stored in the variable x. And in the last line, I'm going ahead and trying to print out that variable x. And you can see that in the output, I'm getting hello there. So this is the basic function of a string, and this is the first type of data structure that we will encounter in our Python programming. But we can also insert numeric strings inside of the variables, just like we did here in the first line. I have supposed a variable which is called string, and I have assigned the value of 1, 2, 3, 4, 5 into that variable. But these numbers are strings because they are written inside the quotation marks, right? So in the second line, what I'm trying to do is adding 1 into the value of the first variable, which is a string. And if you can remember that, integer cannot be added inside the string. So the Python will return us a traceback error, and the type error will be cannot concatenate string and int objects, which means that you cannot add integers into strings because 1, 2, 3, 4, 5 is written in quotes, and hence they are string, and 1 is a number, so string can't be added in numbers. Now it's time for us to understand that what are indexing in strings. But before going into the indexing, we have to understand that strings is actually an ordered sequence of characters. And by ordered sequence, I mean that every character that is written inside a string has a specific location, and that location is defined by the integer. And we can get a single character by calling out that index of the character. For example, here we have a string which is called banana. So the B that is written at the very first place in the string has actually the index of 0. Because in indexing, 0 is the very first position in which a character in the string can be stored. And the next character A will be stored against index number 1. And the next character N will be stored against our index number 2. And that's how, if we want to get a specific character, for example, if I want to print out a single character N from this entire string, I simply have to call out the index number of that character, which is 2. On the right hand side, you can see a simple program in which I have taken a string and then I have allotted that string to a variable which is called fruit. In the next line, I'm actually calling the character that is at the index number 1, which is A. And in the third line, I am trying to print out that character which was written against the index number 1. And you can see that in the output, you got an A. Similarly, in this second example, what I did, I just wanted to print out a character that was written against the index number 2. And you can see that the first character is against 0, the second character is against 1, and the third character, which is N, that is against index number 2. So in the output, you get a character N. So that's how index actually works inside a string. However, you will get an error if you will try to print out the index beyond the end of a string. So for example, here in banana, we actually have 6 characters, which starts from 0 and go up till 5. So what will happen if you want to print out a character that is saved against the index number of 8? You will get a traceback error because the last character had the index number 5. But you wanted to print out the character that had an index of 8, which is absent in this string. So that is why Python will give you an error telling you that your index number is out of range. Often we will have strings that we will use inside of our Python programs, but there's always a way to find the length of that string, which means that we can find exactly how many characters a string contains. For that, we will use a built-in function called len. This function gives us the length of a string. For example, here we have used a string which is called banana, and we have stored that string into a variable which is called fruit. So if we want to find the length of that string, we will write that variable in which we stored our string inside the parenthesis of len, and then we will print out that len function. And you can see that in the output we are getting a number 6. We will write a simple program with the help of which we will be able to find the length of the string that we just stored in our program. First of all, I will suppose a variable x, and then I will assign the input function to that variable, and in that input function I will write a string which is called enter your string. This input function actually helps us to ask the user their input string in the runtime. So what I will do, after getting the input string from that user, I will try to print out that string. But what I want to print out is the length of the string. So I will write len function and I will use parentheses around this x. Now this print function will print the length of the variable instead of just printing that variable x. I will save this file and I will run this program using Python. Right here it is asking me to enter the string. For example, I will write I am John and I will hit enter. You can see that it gave me the output of 9, which means that this string contains 9 characters. You can just go ahead and count the number of characters in your string. In my case, from I to N, I have 9 characters including the spaces. Just like arrays, we can also loop through our strings, which means that we can iterate through the entire characters stored in a string. We can use a while statement, and along with that we can also use an iteration variable and the length function, and we can construct a loop to look at each of the letters in a string individually, which means that this program will print out each and every character of the string along with characters index number. So in the first line I have supposed a variable and then I have stored a string inside it, which is a banana, and then I have used a counter variable, and this time I have named this variable as index, and that variable starts from 0. Now in the third line I am defining that loop, and along with that I am defining a certain condition for which this while loop will be operated. In the body of this loop I am calling out each and every character in the string, and then I am storing that character into the variable letter. And in the next line I am trying to print out the index and the letter that is saved against that index. And the next line is adding 1 to the previous index number, and the same process gets repeated until the condition is falsified. In our case, the length of the string is 6 because banana has 6 characters. So in the first iteration, the index will be 0, which is less than 6. So the condition will be satisfied and the body of the loop will be executed. So according to the second line of the body of the loop, the index number and the letter which is saved against that index will be printed out. The output of the first iteration will look like this: 0 and B. B being the very first character in the string, and 0 is the index of the very first character which is being operated in the first iteration. After printing out this output, 1 will be added to that index. Now 0 plus 1 will be 1. So in the second iteration, the value of index is 1 and the length is again 6. So the condition is again satisfied. And in the second iteration, the second character, which is A, is being printed out against its index number, which is 1. And that is how the loop will continue to operate until the condition is falsified. We can also write for loops to perform the same task, and you can see that for loops are much more reliable and easy as compared to the while loop, because you can take all the work that you got from the while loop just by using one single line of code. That means for loop is much more efficient. So here again I will suppose a variable called fruit, and then I will save a string banana inside the variable. In the next line I will define my for loop, and in the definition of that loop I will write my iteration variable, which is a letter, which means that each character will be stored in this variable letter one by one in each iteration, and the for loop will ask this iteration variable to look inside the variable fruit, and in the body of this loop I am trying to print out the letter one by one. So in the first iteration, the first character of the string will be printed out, which is B. In the second iteration, the iteration variable will move from first character to the second character, and A will be printed out. And that is how the entire string will be processed by using for loop. Here in the definition of the for loop, letter is the iteration variable and the banana is a 6-character string. The block, or it is also called body of the code, is executed once for each value in the sequence, which means that the entire for loop will be executed for each of the item that is present inside the string, and hence the for loop will be executed 6 times because in the string we have 6 characters.
Up till this point, we have gotten familiar with the concept of indexing, which means that we can call out a specific character by calling out the index of that character. But what if I want to print out or get a specific part of the entire string using index? So the process of calling a part of a string is called slicing the strings. We can also look at the any context section of a string using a colon operator. There is a specific syntax for string slicing. Just like we want to call the specific character, we write the variable name and then the index number of that character inside the square brackets. But this time, instead of writing the only index number of that character, we write the starting and the ending index of the part which we want to extract from the string. So that starting and ending index of the character is separated by a colon operator. The second number, which is written after the colon in the square brackets, means that you have to go up till that point, but you should not include that point. In the example, you can see that the index from 0 to 4 is being called out. Now the 0 will be included in the part of the string, but the string will go from 0 to 3 and 4 will not be included. And in the output, you can see that Tony has been printed out. And the same thing will happen in the second example, in which we are calling from 0 to the 6th character in the string. And you can see that Tony space S has been printed out. Here index is also assigned to the space. I will suppose a variable x and I will assign a string to it. Let's say the string is Tony stock, right? Now this string contains 10 characters including the spaces. And after that, what I want to do is print out the sliced string. Now for that, I have to write down the name of the variable in which the entire string is stored. And after that, I have to write the square brackets, and in those square brackets, I have to write colon operator, which here behaves as a string slicer. Now on the either side of this colon, I have to define the limit according to which this operator should slice down my entire string. For example, I'll go ahead and write 0 here, and on the right hand side I will write 7. Now remember, we discussed that the second number, which is written on the right hand side of the column, will not be included in the sliced string. Instead of that, the number less than that number, which in our case is 6, will be included in the sliced string. So these credentials means that I want to slice down my string right from the start up till the 6th character. I will save this file and I will try to execute my file using Python. And you can see that a part of the string has been printed out, and that part starts from the 0th character and goes up till 6th character. And that's how we can just go ahead and play around with these slicers to have a better understanding. For example, this time I want to slice down my string from second index. So I will write 2, and I want to go up till 7th character. So I have to write 8 here, because this 8 will not be included, but instead of that, less than one number of 8, which is 7 in our case, will be included. I will again save this file and I will try to execute this program. And you can see that a part of the string that starts from the index number 2 and goes up till the index number 7 has been printed out. Now that's how you can slice down your entire strings into smaller parts, and you can do the processes according to the program that you're writing. We can use in operator as a logical operator inside the strings. For example, I have a set of characters written as a string, and I want to look for a specific character in that string. So instead of going ahead and writing the entire loop for that, I can just use the keyword in, and that operator will help me in finding the specific character or the string inside my original string. So the in keyword can also be used to see that whether one string is present in the original string or not. The in expression is a logical expression that returns true or false as a result and can be used in if and else conditions. Now, for example, if this operator will find the character you're looking for in the string, it will return the result as true. And if it will not find the character that you're looking in the string, then it will return the answer as false. And that is called being logical expression, because logical expressions always return the results in true and false format. Here I have written a small program in which I have supposed a variable which is called fruit, and I have stored a string inside of that variable. Now in the next line, I want to see that whether that n is present in my string or not. So I will write n in the quotation marks, and then I will write that in operator, and then I will write that variable in which my data has been stored. And after that I will hit enter, and you can see that it returned the answer as true because n is present in my string. And I will do the same for s, but this time the answer will be false because banana does not contain any s in it. Now earlier we said that we can also use this and operator in if-else conditions. In the third example, I have written this small conditional statement in which I have defined my if condition that if n is present in my string, then print found it. And you can see that in the output, found it has been printed out. So we will perform a practical demonstration to understand that how that in works as a logical operator for the strings. For that, we will suppose a variable which is called fruit, and then we will assign a value of a string which is a banana to that variable. And in the next line, I will define a conditional statement if, and after that if, I will define a specific condition which is look for n in fruit variable. And if you find that n character in the variable fruit, then print out found it. Else print did not find. I will save this program and I will run this program using Python. And you can see that the answer is founded because n is present in this string. So let's just go ahead and change this character with s, and again save this file and execute this program. And you can see that this time it gave the answer as did not find, because in this string we do not have any character s. So that's how in operator works as a logical operator for the strings. We will look forward for a quick overview about string libraries in Python. Python has a number of string functions which are in the string library. Just like the functions we used in our previous programming, for example, print function, input function, len function, and other functions that are already built in inside the Python library. Just like those functions, Python also has some functions which are specified for strings only. These functions are already built into the string, and we just implement them by calling those functions in our code. These functions return the new string after some processing without changing the original string. For example, here in the first line, I have stored a string inside a variable x, and in the next line, what I'm trying to do is calling a function that relates to the string, and that function is called lower. Now the output of this function will be that it will convert all the capitals of that string into the small alphabets. So if you will go ahead and print out the output of x.lower, and you will get the answer something like this. Now the string is exactly same, but the capital letters that were present in the original string are converted into the small alphabets. You can use type function
to actually see the type of the data that you're using. For example, in the first line, I have tried to store the data inside a variable, and that data is written inside the quotation marks. So that makes it a string. And you can see that in the output, the Python returned the answer as type string. Now, if you will just go ahead and check the directory of that variable which contains a string, you will find the number of different methods and functions that are stored in that string library. And now you can use all these functions or methods just by calling their name in your Python code. In the previous lecture, we had a quick overview about the string libraries, and we also discussed that we have different functions and methods inside that string library that we can call in our Python program to perform several tasks. So what if I want to try some of those functions or methods so that we can understand how that string library actually works? So in this lecture, we'll just go ahead and try to use a string function to search through a string. Now previously, we used in operator to find a character or a substring into another string. But we can also do that by using a string function called find. We use the find function to search for a substring with another string. Find function finds the first occurrence of the substring, which means that if the character or a substring is present in the original string, then the find function will tell us about the index of the first character of the substring that we are trying to find out. And if the substring is not found in the original string, then it will return -1. And you have to remember that the string position starts at 0, which means that the very first character in a string has an index number of 0. Now, on the right hand side, you can see two examples. In the first example, I have supposed a variable fruit, and I have assigned a string to that variable. And after that, I have supposed another variable which is called position, and then I have used find function. The syntax that we have to follow to use string functions is that we write the name of the function after the variable name with a dot at the center. So in this line, I am asking the find function to look for ONY inside the fruit, which has the string banana in it. And when you will go ahead and try to print out the position, you will get a value of -1 because ONY does not exist in the string banana. Now in the second example, I have changed the string from banana to Tony Stark, and I have stored that in a variable called string. Now again, I am using that find function to look for a substring in the original string, which is stored in the variable string. So I will write string.find, and inside the parentheses, I will write the substring that I want to look for inside the quotation marks. And we know that STA is present in our original string. So on printing that position, we will get the answer of 5. Now remember, we studied that the find function about the index of the first character of the substring which we are looking for. So the Tony Stark is the original string and STA is the substring. And if you compare the substring with original string, you find out that STA's first character is S, which is at the 5th index number of the original string. So in the result, we got 5. That is how we can use find function to look for a specific character or substring inside the original string. What if I want to search through a string? But not only do that, but what if I also want to replace a specific character with another character inside the string? To do that, we have another function called replace. This function also belongs to the string library. The replace function is like a search and replace operation in a word processor. You can look for a specific word or a character, and then you can replace that character with another word or a character. For example, if you have a string which is called hello John, and that string is saved into a variable called x, then you can write this function in this syntax x.replace, and inside the parenthesis you write the character or word that you want to find, and then you place a comma, and then after that you write the word or the character that you want to write in the place of the first. Now after doing that, when you will go ahead and try to print out the result of this new string, you will get hello Bob, which means that John was replaced by Bob. So in this way, we can use replace function to find and replace a specific word, a subscript, or a character in a string. What if your string has some spaces at the start or at the end of it? So there should be a method or a function that can help us in removing those spaces from that string without going to that string in our code and doing it manually. Sometimes we want to take a string and remove white spaces at the beginning or at the end of the string. lstrip and rstrip remove the white spaces from the left and the right side of the string respectively. And strip function removes both beginning and the ending white spaces. For example, here I have a string which has a space at the beginning and at the end of it. Now if I will go ahead and use lstrip function, then this function will remove the space which is on the left side of the string. And you can see that in the output the space has been removed, but the space which is present at the end of the string is present there. Just like that, we can also use our strip function, but that function will only remove the space which is on the right side of the string. In other words, it will only remove the space that comes at the end of the string. And you can see that in the output, the space which was at the end of the string has been removed, but the space which was present at the beginning of the string is still there. But we have another function called strip function. This function can be used to remove both beginning and the ending white spaces in a string. You can see that in our string we have space at the beginning and another space at the end. We can use a strip function to remove both of these spaces. And you can see that in the output the spaces which were present at the beginning and at the end of the string has been removed. And that is how strip function helps us in removing the unwanted spaces from our string. What are prefixes and what role they can play in our strings? Prefix is a word or a letter with which a certain line or a string starts. Now for example, you have a file and in that file you have very large number of lines, and from that file you want to extract certain lines which start from a specific word. So in that case, prefixes can be used in order to extract those specific lines. We can use a function called starts with to find the string that is being started with a specific prefix. For example, here I have taken a string I am John Walker and I have assigned that string to a variable. Now I am using starts with function to verify that if my string starts from a specific word or letter or not. Now the word or the letter that you want to use as a prefix should be written inside the parentheses under quotation marks. Now if the string is starting from that letter or word, then the answer should be true, and if not, then the answer should be false. Now you know that Python is case sensitive, so in the second statement I tried to look for I in lowercase, but in the string I had I in uppercase. Now because both of these characters are different, that is why Python has returned the answer as false, because the string is starting from the capital I, not with small I. So that is how we can utilize these prefixes in order to extract certain lines from the string or a file. In this lecture, we'll go ahead and see that how we can perform parsing and extracting in a string. Now, if you remember the concept of string slicing, then this should be pretty easy for you. For example, here I have a data, I am John Walker %, and I am going to do string parsing and / extraction. Now I will put that data into a string and then I will assign that string to a variable x. Now I have placed two special characters. The first one is % and the second one is / just to perform the string parsing. I am going to extract the part which comes between the % and / and print out that part separately. So what I will do, first of all, I will look for the position where the % character actually is, and I will use my find function to look for the index number of % character. Now after printing out that pos variable, I will get a number of 17, which means that my % character is at the index number 17. And I will do the same to find the index number of second special character, which is /, and we will get a number of 59. Now what I want to do is I want to extract the part that is written between % and /. So here I will perform string slicing. So what I will do, I will write the name of the variable from which I am going to extract a part of a string, and then I will write the square brackets, and in those square brackets I will write colon operator. On the left hand side of that operator, I will define the index number from which I want to start parsing the string. On the left hand side of that colon operator, I will define the index number from which I want to start parsing the string. And on the right hand side, I will define the ending point. The second number cannot be included in the parsing, which means that if I write npos as the second number, which gives the index number of 59, then the characters till 58 will be printed out. And the first character is always included in the string slicing, which means that % will be included in the output. And we don't want that. We want the string to start from end. In that case, I will add 1 to the index of %. In this way, I will ignore that % and the new string that I'm getting in the result will start from end. And when I will try to print out the value of y, I will get in the result, and I am going to do string parsing end. So that's how you can perform string parsing using string slicers. In Python programming, we will often have to deal with file processing. So in this chapter, we will learn that how we can manipulate or process a file that contains a text. A text file can be a document that contains a sequence of lines. For example, here I have multiple lines written as text. If these lines are saved into a file, then that file is called text file. In order to work on a file, we must have to open that file first. And after that, we have to let the Python know that which file we are going to work on. So to do that, we use a function called open. We add the file handle, which is also called file name, in the open function, and a variable to tell the function that what we intend to do with that file. In other words, we will tell the open function that we want to read the file or we want to write something into it. So the syntax will be like, we will suppose a variable in which the file will be stored, and then we will write the open function to open that file, and in the parentheses first we will write the file name, so the Python will recognize which file it has to open. And after comma, we have to define the mode. Mode is usually set to R if we want to read the file and to W when we want to write the file. Consider a handle to be as a variable through which we can manipulate or control the file. In the previous lecture, we saw that how we can store a string into a variable. But in this case, instead of saving a single line as a string, we are saving a file which contains multiple lines. Here handle is exactly like the variable in which we stored our string. And once we have saved our file in that variable, we can call that file at any point in the Python code using that variable. You have to remember one thing. In the file, whenever you move from one line to the new line, at the end of the first line, there's always a character which is known as \n, which generates the new line. In other words, \n sends the line to the new line. This \n is also considered as a character in the file. For example, here we have multiple lines in a text file, and at the end of every line there is a character that we cannot see, but it is always there, which is known as \n. This character creates the new line. So if you will go ahead and find the length of that file, you will find that these \n characters are also counted to find the length of the file. The previous lecture was mainly about how we can open up our file for file processing in our Python. And in this lecture, we will move ahead and we will discuss that how we can handle that file and how we can read that file as a sequence of lines or words. So first of all, we know that open function is used to calling out the specific file. Then that file can be treated as a sequence of lines, which means that every line of the file is a string in sequence. Now loops can be used further to go through the entire file. For example, we can use these loops to go through every single line of the file and perform parsing and extraction. Here I have written a simple program. In the first line, I am trying to open up a file which has name file.txt. And in the next step, I am defining a for loop in which I want to print out each and every word inside that file. So this portion of the code right here will go through the entire file and print out every word in the file. Now we can use loops to count and print the number of lines in the file. For example, in the first line here, I have used open function to open a file named as file.txt. In the next line, I have defined a counter variable which starts from 0, and with each line 1 will be added to that counter. You can see that in the body of the for loop 1 is being added to the previous value of the count after each iteration, and that's how at the end of the program or at the end of this loop we will have the total number of lines that are present in the text file. We can also read the entire file as a string. So the first line is like always opening the file.txt. After that, I am using a string function which is called read, and that function will go through the entire file and read each and every word that is present in that file. And after that, we will save the value that we will get after using that string function, and we will store the value in a variable which is called input. And in the next step, I have used length function to find the length of the string. In other words, this read function has converted the file into a single string. Now the length of that single string can be found by using length function. And you can see that in the output the number of the lines are being presented. You can also perform parsing and extraction using string slicers. In this line, you can see that I have written the name of the variable from which I want to parse a substring, and I have written the square brackets after that variable name, and inside those square brackets I have written a colon operator. On the left hand side of the colon operator there is nothing written there.
but on the right hand side of the operator 30 has been written, which means that I want to start from the very beginning of the file and I want to go to the character that has the index of 29. This line right here is printing the length of the file, and this statement is being used for parsing and extracting some of the data. Now because I have defined an ending point as 30, this means that some part of the file will be extracted up till 30 characters. But the character which has 30 index is not included in the substring, which will be passed after executing this statement. Here I have written a very simple program that will open up a file and it will go through the entire file and it will select the specific lines from that file using the prefix property. And for that I will use starts with function, and in the function I will write the prefix that I have to look for inside the file. And in the body of that conditional statement I am trying to print out those lines. So during each iteration the line which contains that specific prefix will be printed out. This portion of the code right here will print out all the lines that starts from subject, and here subject is the prefix. So in this lecture we're going to see that how we can manipulate and handle a file which contains the text consisting on the multiple lines. For example, I have taken this file which is named as document.txt. I will open up this file and you can see that this file has all these strings in it. You can see that there is a specific line at the start of each paragraph, and that line starts from subject, right? You can see that the subject is written here too and here too and all the way till the end of this file. So I will use this file as an example and I will try to manipulate this file and I will try to print the lines which starts from subject. So what I'll do, first of all I will just go ahead and move to the folder where I have saved my file, and then I will list the items to see that if I can see my file here. So here you can see the name of your file, which is document.txt. What I'll do, I will just clear out this terminal and I will create a file here named as file processing.py. And you can see that the file named as file_processing.py has been created. So what I'll do, first of all I will suppose a variable, and in that variable I will open up my file, and the name of the file was document.txt. So this statement is actually asking to open up the file which is named as document.txt and then saving that file inside this variable. So in order to verify that my file has been assigned to that variable or not, I will print out that variable. I will save this file and I will execute this file using Python. Now you can see that instead of printing out the entire file, it just showed me that the file named as document.txt has been opened up in reading mode, right? So what I want to do is I want to print all the lines which start from subject word, which means that I have to use the concept of prefixes. Now for that I have to use a function called starts with. First of all I will define a loop in which I will look for line inside the variable x, and this variable x contains the entire file in it. I will write colon operator and then I will hit enter. Now inside this loop I will go ahead and define a conditional statement, and I will say that if the line starts with, and in the parentheses I will define the prefix which is subject, then print that line. After that I will get outside of this conditional statement and I will again hit backspace and get outside of the loop body. Here I will print out the process is done. I will save this file and I will try to execute this program using Python. Here you can see that all the lines which were started from the word subject has been printed out here, skipping all other lines that were present in the text file. And after that, the process is done is printed, just like we asked this program to do at the end. So that is how we can use open function to open up a file, and then we can go through that entire file using a for loop, and we can also extract some specific lines on the basis of their prefixes. In this lecture, we will create an elegant program that will print all the lines which will start from a specific word subject. So the program that we made in the previous lecture was pretty simple. But this time, we are gonna choose a more elegant way to perform that same task. The program should follow all these steps. At the first step, whenever the user runs this program, the program should ask for the file name from the user in runtime. And after the user enters the file name, in the next step, the program should try that file name and see whether the program finds that file or not. In case the file is found, the program should open the file in the next step. And after opening the file, the program should be able to count the number of lines starting from 0. After that, the program should look for specific lines which starts from the prefix subject. And when the program finds those lines, it should print out all those lines. So the program is a bit more complex and long as compared to the program that we made in the previous lecture. In this project, we're gonna use all the knowledge that we have get so far from the chapter 1. So now we will move ahead to our Visual Studio Code to write the code for this program. Here I have this text file named as document.txt, and I will use this file as an example, and then I will perform the file handling tasks using Python. You can see that inside this file there are a couple of lines written as strings, and in each paragraph we have a subject line. You can see that every subject line is different from the previous subject line. Now we will use this text file in order to write the appropriate code for file handling. Now in the same folder where this file has been saved, I will open up my Visual Studio Code, and I will create a file named as file processing.py. Now, according to the instructions, at the very first step, the program should ask the user to enter the file name. So for that, I will suppose a variable which is file name. And then I will use the input function to grab the input from the user during runtime. And in the parentheses, I will write the message that the user will see. And it will be enter the name of file. And according to the next instruction, the program has to try the name of the file, and it should decide whether the program found the file or not. For that, I will go ahead and use try and except structure. In the try section, I will suppose a variable x, and then I will use the open function to open that file which the user just entered. So in the parentheses, I will provide this function with the username, which is stored in the variable file name. And after that, if the file is found, the program should print out found the file. But if the program cannot find the file, then the program should jump to the except section and print out file does not exist. Now in case the file is found, then we have to write a loop which will go through each line inside the file. And for that I will use for loop, and I will ask this loop to go through each line in variable x, and by variable x I mean inside the file which is stored in this variable. Now inside this loop I will just go ahead and try to count the number of lines. And for counting purposes, we have to define a counter variable before starting the loop. So here I will suppose the counting variable as count, and the value of count will start from 0. Now in the body, I have to write a statement which will count all the lines that are present in the file. So after each iteration, this one will be added to the previous value of count. And that is how we will get the total number of lines at the end of this program. Now in the next step, I have to look for the lines which start from subject. And for that, I have to write a conditional statement with an appropriate condition. So I will write if line starts with subject, here subject is a prefix, then print out that line. So this condition will be checked over and over again until this loop is continued to be executed. And after each iteration, the number of lines will be increased until the program will reach at the end of the file. Now what I will do, I will just get outside the body of this if condition, and after that I will again get outside the body of this for loop. And here I will go ahead and write print the total number of lines in the file are. And after that, I will write the variable name in which the number of lines were being stored. And at the end of this program, I will try to print out that the process is done. So that's it. I think this should be enough to run our program more elegantly. So I will save this file and I will try to execute this program using Python. I will hit enter, and you can see that the program is asking the user to enter the file name. So I will enter the file name, which was document.txt. I will hit enter, and you can see that in the very first line, the program returned the answer as found the file. And after that, it went through the entire file and printed out all the lines which were started from the word subject. And after that, the program printed out the total number of lines that were present in the file, which is in this case is 29. And at the end of this program, the process is done has been printed, which shows that the program has been executed completely. So that is how we can use our input function try and except structure, string functions such as starts with, for loops, and conditional statements in order to create this specific program. Another method in which we can structure our data is known as a Python list. So chapter number 8 is all about understanding those lists. First of all, we have to understand that what is the difference between algorithms and data structure. Algorithms include the steps that we follow to write a specific program. On the other hand, data structure are the ways or methods in which we organize our data inside a computer. We can organize our data as a string, as a list, as a dictionary, and as a tuple. Now we have to understand that what is the difference between collection and not a collection. Generally, a collection allows us to put many values in a single variable. Through a collection, we can contain multiple values in one package.
So through one array, we can assign multiple values in one package to a variable. But most of our variables have one value in them. When you put a new value in the variable, the old one is overwritten. For example, if you assign a string to a variable, and after that, in the next line, you assign a different string in the same variable. Now, instead of adding both the strings in the same variable, new string actually overrides the old one. So in that way, we can classify a string as not a collection. A list is a collection, which allows us to put many values in a single variable. You have seen this kind of expression in the previous lectures, in which we assigned a number of elements to a single variable through square brackets. Everything that is written inside these square brackets are the list constants. And these are the items that the variable x actually contains. So whenever you will go ahead and add another item into this list, instead of overwriting the previous value, the new item will be added into the previous value. List constants are surrounded by square brackets, and the elements in the list are separated by commas. A list element can be any Python object, even another list. In other words, you can also place a list inside of another list. Also, a list can be empty too. Same as strings, we can also process or list through loops in a Python program. So here I have a list X, and I have stored John, Walker and Bob constants inside that list, and I have written a loop to print out the name of the person one after the other. So for that, I have defined a for loop, and I've used the iteration variable name, and then I have written the in operator and then the variable in which my list has been stored. So this statement right here is actually asking Python to look for name inside the variable x, and in the body of the loop I am trying to print out the name of the person, and then I have written the variable name, which means that for the first iteration, the very first constant inside the list will be stored in the iteration variable name. Hence the output will be name of the person is John, and in the next iteration the iteration variable will move to the next constant, which is Walker, and hence the result will be name of the person is Walker. Similarly, we can just go ahead and perform multiple exercises just to get a good grip of the working of these loops for a list. Now, same as a string, a list is also an ordered set of data, which means that every element that is present inside the list has a specific index number. In our current list, we have three names. First is John, then comes Walker, and then comes Bob. So because John is the very first entry in our list, so its index number will be 0. Because we know that in an ordered set of data, the index number always starts from 0. So for example, I have this list in which I have three elements. First is John, second is Walker, and third is Bob. And I'm gonna use the index number to extract Walker. So because the Walker is the second element, so I have to put one index just to call that element. Now in the second line, you can see that print x, and in the square brackets I have written 1. And as soon as I will execute this program, the output will be Walker, because 1 is the index number of Walker in a list. Lecture 3 mainly deals with the mutability of a list in Python. The ability to change the content is known as mutability. Strings are immutable, which means that we cannot change the contents of a string. Whenever we will try to alter the content of the string, the Python will give us an error. But that is not the case for lists. Lists are mutable, which means that we can change the content. In other words, we can change the elements of a list by using their specific index numbers. Now you can see that here I have a string which is called I am a string. So whenever I will try to change the content of this string, which means that I want to change a specific character in that string,
the Python will give me an error. And you can see that in the second line, I'm trying to change a character which is stored against index number 3. And I want to change the character from M to F. And whenever I will try to execute this program, the Python will give me a traceback error. But that is not true for list. You can see I have a list which contains 3 elements, John, 2 and 3 inside it. Now I can change the elements inside a list. I can also add elements and remove some elements from the list. You can see that in the second line, I'm trying to change the second element of the list, which is 2. For that, I'm calling the index number of 2, which is 1, and I'm assigning a new value, which is Walker, to that index number. Now, whenever I will go ahead and try to print out this program, you can see that the new list is John Walker 3. You can notice that the second element of the list has been changed from 2 to Walker. So this property of the list makes them mutable. We can also find the length of a string using a Python built-in function. Just like the strings, len function can be used to find the length of a list. In a string, the len function actually counts the number of characters that are present in that string and gives the number of those characters as the length of a string. Similarly, len function can tell the number of elements in the list. Here I have 3 elements inside a list which is stored in variable x. You can use len function to find the number of elements that are present in a specific list. So after printing out the len function corresponding to the variable in which we have stored our list, we will receive an answer of 3, which means that our list contains 3 elements inside it. We can also do some exercises to understand that how we can use len function to find the number of elements inside a list. I will go ahead and suppose a variable x, and I will assign a list to that variable. In that list, I'll just go ahead and create some constants. For example, John, Walker, Steve, David. Now, here I have a list which contains 4 names inside it. I can use a len function to find the number of elements of this list. And for that I will write print, which will obviously print out the result. And in that print, I will write my len function. And I will add the parentheses for that function. Now inside the parentheses of len, I will write the name of the variable, which is x. I will save this file and I will try to execute this program using Python. You can see that in the output it has printed 4 because the number of elements in our list were 4. So that is how you can use len function to find the length of a string in Python. Now we will understand the use of range function in Python. The range function returns a list of numbers that range from 0 to 1 less than the parameter. And by parameter, I mean that number that we enter inside the range function. Now we can use this range function to print out the indexes against the elements that are present in a list. We just studied that the range function returns a list of numbers that ranges from 0 to 1 less than that parameter. So for example, I want to print out the numbers until 4. So I will write that parameter 4 inside the range function. And you can see that in the output, it printed out from 0 to 3. Now 3 is 1 less than that parameter 4. Now we can also use this range function to print out the indexes of the elements that are present in the list. Now for example, here I have a list which contains 3 names, John, Walker and Bobo. Now first of all, I have to find the length of that list. Now for that, I will use a function called len. And after that, I will put the answer of that length function inside the range. And then I will print out the output of that range. Now you know that the length function will return the value of 3 because there are 3 elements inside the list. And after that, that 3 will be inserted into the range function, which will get the output from 0 to 2. Now 2 is 1 less than the parameter 3. And after that, the print function will print out the result that is stored inside the range function. Now these are the indexes of the elements that were present in our list. Now, as we will move ahead into the complex programming in Python, we will see the multiple uses of this range function. Just like strings, we can also perform concatenation for lists, which means that we can add multiple lists to get a new list using a plus operator. Here we have two lists. The first one is X and the second one is Y. The first list contains 6 elements, which are 1, 2, 3, 4, 5, and 6. And Y list contains 3 elements, which are John, Walker, and Bob. Now we can add both of these lists, and that's what called concatenation. And as a result, you can see that the elements of both lists are printed, which means that both of them were added successfully. So this is how we can perform list concatenation in Python. But even after adding them, you can just go ahead and print out both of those lists individually. So for that, I will just go ahead and print out the variable name of each list, which is in the first case X and in the second case Y. And you can see that in the output, the elements of both of these variables has been printed out respectively. I'll just go ahead and create a list. I will suppose a variable and I will assign a list to that variable. And after that, I'll just go ahead and slice out that list. I will suppose another variable Y, and in that variable, I will save the list after slicing. For that, I have to define a slicer. And I will write the variable name of the list, which is X. After that, I will write square brackets, and in those brackets, I will write a colon operator. Now, on the left side of this colon operator, I will define a starting point, which is 1. And on the right hand side of this colon operator, I will write the ending point of this slicer. Now these numbers that are written on the either side of a colon are actually the index numbers of the elements that are present in this list. And second number is always up to but not including. And after that, I'll just go ahead and print out my Y variable. I will save this file and I will try to execute my program using Python. And you can see that a sublist has been printed out, which starts from index number 1 and ends at index number 4. So that is how you can perform list slicing. Now we can just go ahead and perform several exercises. For that, I will just go ahead and suppose another variable, which is Z, and I will perform slicing again, but this time I will change my starting and ending points. For example, I will write 3 here, and on the right hand side I will write 6, which means that the slicer will print the elements from the index number 3 to index number 5, because 6 is always up to but not including. And after that, I will print out the value of Z. I will save this program and I will run this program. You can see that in the second line, we have another substring which starts from the index number 3 and ends at the index number 5. I will just go ahead and clear out this terminal, and after that I will comment out all this code to disable it. And now we can create a list, and we can also check the list methods that Python can provide us. So for that, I will suppose a variable X, and in that X I will assign a list. So this is a function which creates a list but at this point that is an empty list. After that, I can use type function to check the type of variable x, and I will print out that answer. I will save this program and I will run this program using Python. You can see that in the result, the Python has returned an answer which is class list, which means that whatever that is stored in this variable is a list. Now you can just go ahead and print out the directory of this x variable. I will save this program and I will run this program. And these are all the methods that we can use in a list inside Python programming. Until now we have used the lists which had all the elements in them already. But we can also create a list from scratch. We can create an empty list and then add elements using append method. Now the list stays in order, which means that the new elements which are added in the list will be at the end of the list. So for that we can first of all create the list using list function, and after that we can use the append method in order to add multiple elements inside the list. So we will just move to our Visual Studio Code so that we can get a hands-on experience at how we can create lists inside Python program. So that we can get a hands-on experience, that how we can create a list using in Python. Now first of all, I will just go ahead and suppose a variable x, and I will assign a list function to that variable, which means that I have created a list which has no element inside it. Now after that, I will use a method called append to add multiple elements inside that list. So here x is the list and append is the method that will add whatever is written inside these parentheses. Now before adding anything, I'll just go ahead and print out my x to see what this list has already got inside it. I will save this program and I will run this program using Python. And you can see that it has printed out a list, but there is nothing inside these square brackets. Now I will comment out this line and I will enable this line again, and I will write an element inside these parentheses. For example, we can write John. Now this append method will add this element inside the list, which is x, and after that I'll just go ahead and print out the x. Now I'll save this program and I will run this program. Now you can see that an element John has been saved in the list. Now I can do the same again. I can use append method, and this time I can store a number inside the list. I will save this program again and I will execute this program again. And you can see that 1 has also been added into the list. Now we can just go ahead and add multiple elements inside the list, which are Walker, 34, Bob. I will save this program and I will run this program using Python. And you can see that all those elements have been added into the list. And you can notice that every element that I am adding in that list has been added at the end of the list. So the list is an ordered set of data, which means that the very first element which is added into the list will stay at the first position, and the element which is added at the second place in the second number. And that is how we can create a list in Python. No matter what element you add into the list, it does not disturb the order of the previous elements. So that is why we call a list in Python as an ordered set of data. Now we will see that how we can search for a specific element inside a list.
In Python, in and not in operators are used to let you check if an element is in a list or not. These logical operators returns true or false as an output. For example, I have a list here which contains numbers right from 1 up till 9. Now if I want to check that number 5 is in the list or not, all I have to do is write 5 and then use in operator, and after that I will write the name of the variable in which the list is stored. And when I will just go ahead and execute this program, I will get the output as true because 5 is present in that list. And we can also check whether 16 is inside the list or not. But in this case, we will get the answer as false because in the list we don't have any number 16. Now we can also use not in operator inside list. For example, I have to check that if 90 is present in the list or not. So I will write 90 and then not in, which is the logical operator, and then the variable of the list, which is x. And I will get the answer as true because 90 is not present in that list. So according to the logic which was not in, the answer will be true. Now suppose the element 90 was present in that list. In that case, not in logical operator would give me an answer of false. But in and not in operators actually reduce the code in Python and replace the code for loop in a single line. And using these operators, we will just have to write a single line which will perform the task of all the multiple lines that we had to write for a loop. Strings and lists are closely related to each other. So we can convert our strings into a list. We use a split function that breaks the string into parts and then creates a list of the strings. Those small lists of string can be known as words. I will assign a string to a variable x, which is I am a string. And after that, I will use the split method to convert this string into a list. And for that, I will suppose another variable in which I will store the value that I will get after using split method, and after that I will use the assignment sign, and then I will write x dot split, and after that I will write parentheses, but there is nothing written inside these parentheses. Now I will try to print out the value of y. I will save this program and I will run it using Python. Now you can see that the entire string has been converted into a list, and the splitting has been done on the basis of white spaces. But we can also define a specific delimiter character on the basis of which we can split a string. So I will just go ahead and comment out this entire code, and I will suppose x again, and this time I will just go ahead and write a string. I am a string. But at some places in the string, I will write semicolon instead of spacing. And after that, I will perform the splitting method again. But this time, in the parentheses, I will define my delimiter character, which is semicolon. Basically, I'm asking this method to split this string on the basis of semicolon, such as wherever we have this semicolon, on the same places I want to perform splitting. So I'll just go ahead and print out y. I'll save this program and I will run this program using Python. You can see that even if I had a space here, splitting has not been done because this time I have defined a specific delimiter character. So Python will look for a semicolon to perform splitting. And you can see that wherever I had this semicolon, at the same point Python has done splitting and has converted that string
into a list. Splitting can be very useful if you want to extract a specific word from the given data. So we have to look deeper inside the splitting patterns. We have a double split pattern in Python. Consider this a nested split pattern in which we split an already splitted string to get a specific word. Sometimes we have a data in which we will split our strings into pieces and then split those pieces again. For example, here we have a string and we want to extract the xyz.com from the given data. Now there are multiple steps that we have to follow in order to perform this task. The first step is splitting the entire string into small parts, and step 2 is extracting that example @xyz.com part from the string. And third step is splitting that substring again. And step 4 is extracting the xyz.com part from that substring. So we will go ahead and create this project in which we will perform double split pattern to extract xyz.com from the given example. I have this string stored in variable x and I want to extract this part of the string from the entire original string. For that, I will go ahead and perform the process of string slicing, and I will convert this string into a list of substrings. And after that, I will split an already splitted substring to get xyz.com. I will suppose a variable y, and then I will go ahead and split my original string using split method. And you can see that at this point nothing has been written inside the parentheses. In this case, the split method will split the entire string on the basis of white spaces that are present in that string. So if I'll just go ahead and try to print out the value of y, for that I will save this program and I will run this program using Python. You can see that the entire string has been converted into a list which contains substrings. Now those substrings can also be known as words. Right? Now what I have to do, I have to resplit this substring to get my xyz.com. Now for that, I will just go ahead and comment out this line. Now I will again split the list which is stored in y, but I have to split the second element of that list. So first of all, I will suppose a variable z and I will call the second element which has index number 1. Now right now the list is stored in y and I will use square brackets to call that object which is stored against index number 1. Now if I'll just go ahead and try to print out z, and I will save this program and I will run this program again, you can see that example @xyz.com has been printed out. Now I have to resplit this object, but this time I want to split this substring on the basis of @. So I will just comment out this line again, and this time I will go ahead and suppose another variable and I will use split method again. But in this case, I will define a specific delimiter character, which is @ in this case. Now after that, I'll just go ahead and try to print out the value of g to see my output. I will again run this program and you can see that the entire string has been divided into two separate words, and that splitting has been done on the basis of this @. Now I want to extract this part from the list. So I will just go ahead and comment out this line, and after that I will suppose another variable age, and in that variable I will call my second element of this list, and this list is stored in g. So I will write g and then I will write square brackets, and because I want to extract this second element, so this second element will have index number 1, So I will just go ahead and write 1. And after that, I'll just go ahead and print out the value of age to see the output. I will save this program and I will run this program. And you can see that xyz.com has been printed out here. So we have extracted xyz.com from this long string and we have used double splitting method.
In chapter 9, we will discuss about the Python dictionaries. You will understand that how we can use these dictionaries in order to structure our data in Python programming. But first of all, we have to recall the difference between a collection and what's not a collection. A collection is a set of a data we can carry around in one single package. In other words, multiple values can be stored in a single variable. But on the other hand, most of our variables have one value in them. Whenever we try to put a new value in the variable, the old one is overwritten. Here you can see that we have defined a list, and a list is a collection that contains multiple values. And on the other hand, you can see that I have assigned a value of 2 to the variable x, and in the next line, I try to add another value in the same variable x, but after printing out the value of x, I got an answer of 4 instead of 2 and 4, which means that the value has been overwritten in the variable x. So this type of data is not a collection, because instead of adding all the entries in the same variable, the new entry has overwritten the previous one. Now we have two types of collections. The first one is list and the second one is dictionary. A list is a linear collection of values that stay in order. Now this list in some ways is similar to strings and tuples, but dictionary is a different type of collection. Consider this as a bag that contains values, and those values have labels attached to them, which means that in a list we had elements saved against their index numbers, and those index numbers were always in order. But in the case of dictionary, we have labels instead of these indexes, and the values that are stored in the dictionaries have no order. Dictionary is just like a bag which contains multiple items, for example keys, pencils, notes. Each of that item contains a label which is called its name. Dictionaries are Python's most powerful data collection. They give us facility to perform fast database-like operations in Python. We do not have to create a separate SQL database file. Instead of that, we can just go ahead and use these dictionaries to create database. We can use the curly brackets to define these dictionaries. And we have multiple names for these dictionaries in different programming languages. For example, in PHP or Perl, we call them as associative arrays. In Java, we call them properties or maps or hash map. And in .NET and C, we call them property bags. Now a list indexes its entries based on the position in the list. But dictionaries are more like bags, which means that the dictionary never stores its entries in a specific order. The entries can be saved in random order inside the dictionary. So we index the things we put in the dictionary with a lookup tag. And that lookup tag is called label. Here we have an example in which in the first line I have created a dictionary by using dict function. At this point, the dictionary is empty. Now in the next line, I am trying to add an entry inside that dictionary. So for that, I have to write the name of that dictionary, and after that, in the square brackets, I have to write the label of the entry. For example, the first item that I want to add in the dictionary is money. So that lookup tag will be called money. And after that, I will assign that lookup tag an entry, which is 12. And the same goes for other two items, which are called phone and name. Now, after adding these three items, I will go ahead and try to print out the dictionary. And you can see that in the curly brackets, the Python has returned the value of dictionary, in which the first item is money, which has an entry of 12. And in the second item, we have name, which has an entry of 56. And in the third place, we have an item, phone, which has an entry 4 in it. And you can see that in the first place I added money, in the second place I added phone, and in the third place I added name. So if we were talking about lists, then the output would be in the same exact order. But in this case, you can see that name and phone entries have interchanged their order, which means that the dictionaries does not have to be in any order. These curly brackets are for dictionaries. Both the dictionaries and the lists are the ways in which we can structure our data. In this lecture, we will discuss then what is the difference between a dictionary and a list. Dictionaries are just like lists, but they use keys, in other words called labels, instead of index numbers. Whenever we try to save our data inside lists, that data was saved against a specific index number. But that is not the case for dictionaries. The dictionaries don't have index numbers. Instead of that, they contain labels. And the other difference is a list stays in order, but dictionaries don't have to be in order. Here you can see that I have created a list by using a list function. And after that, I'm using append function to add entries inside of that empty list. And after printing out that list, you can see that the elements inside the list have the same exact order in which they were added inside the list. Moreover, you can use index numbers to call a specific entry from that list. But on the other side, we have dictionary. We will create a dictionary using dict function. And unlike lists, we use labels to add the entries inside that dictionary. We will assign a name to a specific entry, and that pair will be added inside the dictionary. You can see that after printing out, we have all the data in key value format. Now, instead of using the index number, you can call out a specific value by using its label. Just like a list, dictionary also have literals, in other words constants, and dictionary literals use curly braces and have a list of key value pairs. You can make an empty dictionary too. Here in the first line we have dictionary that has literals inside it, and in the second line we have an empty dictionary because this dictionary does not contain any constant inside it. We can also count down the words inside the dictionary. One of the most common uses of the dictionary is counting how often we see something. So for example, I have a dictionary and I have assigned that dictionary to variable x. And after that, I just go ahead and enter two entries inside that dictionary. Name of the first entry is 1 and the label of the second entry is D. So when I will print out this dictionary, you can see that here I have a dictionary which has two items. The first one is D and the second one is 1. And both of these entries occurs only one time in this dictionary. But what if I enter another item which has the same name as 1? In this case, the occurrence of 1 will be added to the previous value of the occurrence. And now if I will print out the value of dictionary, you can see that D is occurring only once, but this time 1 is occurring twice because we entered another item which had the same label as 1. We will get an error when we try to find out an item that is not present in the dictionary, and we can use in operator to see if a key is in the dictionary or not. Here you can see that we have a dictionary that is stored inside a variable y. And that dictionary contains two items. The first one is 2, which is stored against a label John, and the second item is 4, that is stored against a label Walker. So when I will go ahead and try to print out an item which has a label Bob, I will get a traceback error because in the dictionary I have no item which contains the label Bob. And here you can see the use of in operator inside the dictionary. You can write the name of the label and then in operator, and after that you can type out the variable in which you have stored the dictionary. And that in operator will help you to see whether the label is present in the dictionary or not. Now you can see that at the very first line I have initiated a dictionary, but at this point the dictionary is completely empty. So when I will go ahead and try to check whether that dictionary contains an item labeled as John, then it will return me an answer of false, because at this point the dictionary was entirely empty. But in the next example we have number of elements inside a dictionary, and when I will go ahead and try to check whether I have 4 inside a dictionary or not, it will return the answer as false again, because you can see that in the items present inside a dictionary we do not have 4 elements inside it. Now let's see that how we can count down the words inside a dictionary. Whenever we encounter a new word, we need to add a new entry in the dictionary, and if this is the second or later time we have seen the name or the word or the label, we simply add 1 to the count in the dictionary. And we will perform this task using loops. So let's see the practical approach in which we can count down the words that are present inside a dictionary. Now first of all, we'll just go ahead and generate a dictionary, and then we will assign that dictionary to a variable through which we can handle or manipulate that dictionary. So first of all, I will suppose a variable which is called dict to store the dictionary, and after that I will assign that dictionary to that variable using assignment sign, and through this function I will generate a dictionary. Now after that I will insert a list of name inside the dictionary. So I will use names as a variable name for that list, because in that list I am going to store multiple names. For example, John, Walker, Steve and Tom. And after that I will write a loop that will iterate through the entire list and see that how many times a specific name has occurred inside that list. So for that I will write loop, and after that loop I will write the name of the iteration variable, which is name. So I'm asking this loop to look for a specific name inside this variable in which this list has been stored. So I will write in operator, and then I will write the variable name in which the list has been stored. After that I will add indentation, and inside the body of the loop I will define a conditional statement which will look for the word count. So for that I will write if the name not in dictionary. Now this statement means if the current name in the first iteration is not inside the dictionary. In other words, if this loop has not seen the specific name in the dictionary before, so what will this loop do? So in the body of this condition I will write dict name is equal to 1, which means that if you have not seen this word before inside the dictionary, then just assign the value of 1 to that name. In other words, this statement tells us that the specific name has occurred only once inside the dictionary. But what if a name in the list occurs more than one time? So for that we will write the else section of this condition. Now in this section we will write dict name is equal to dict name plus 1. Now this statement tells us that if you have seen a specific name more than one time, then just add 1 to the previous value of that name. So for example, in the dictionary we have a name 2 times. So in the first iteration, the count of that name will be 1, and in the next iteration the loop will see the exact same name again, and this time it will add 1 to the previous value of that name, which in the previous iteration was 1. So 1 plus 1 is equals to 2. And when we will print out the output of that count program, we will see that in the dictionary against name John, 2 will be printed out, which means that in the dictionary John is present 2 times. Now after that I will get outside of this conditional statement, and after that I will again get outside of the body of this loop, and here I will print out the dictionary. I will save this program and I will run this program using Python. Here you can see that all the names inside the dictionary occurred only 1 time, because in the list the names are written only once. But what if a specific name, let's say John, occurs more than 1 time? So I'll just go ahead and enter another John in the list. I will save this program and I will run this program again. You can see that all other names occurred only once, but this time against this name John, 2 has been printed out instead of 1, which means that John occurred twice in the list. So that's how you can count down your words inside a dictionary. Now we will see that how a Python will return us a traceback error whenever we will look for an item that is not present inside a dictionary. So for that I will just go ahead and create a dictionary, and I will store that dictionary inside a variable x. So for that I will write curly braces and I will write items in those brackets. So for example, as the first item I will write a key name money, and I will store 34 inside that label. Again write a label name which is phone, and this time I will write a value of 45. And after that I will write third item and I will assign a label to that item as bag, and I will assign the value of 56 to that label. So what if I just go ahead and try to print out a specific value from the dictionary? So in the first step I will try to print out an item that is actually present inside that dictionary. Let's say I want to print out money. So for that I will write the name of the variable in which the dictionary has been stored, and after that I will write square brackets, and in those square brackets I will write the label of the item that I want to print out, which is money. So I will save this program and I will run this program using Python, and you can see that the value that was stored against label name money has been printed out. But what if I just go ahead and try to print out name? And you can see that we do not have any item inside a dictionary which has label as name. I will save this program and I will run this program using Python, and you can see that this time the Python returned us a traceback error, because we do not have any item inside a dictionary with this label name. In the previous lecture we used loops to count down the words inside a dictionary, but we can perform the same exact task using a different method which is called get method. We can actually count down the number of times a word is repeated inside a dictionary. But get method can reduce the entire loop into a single line of code, and that makes our coding a lot more faster. Earlier we wrote down this entire code just to count down the words inside a dictionary. But this entire conditional section can be reduced to a single line of code using get method. This line does the exact same task what this conditional section do. It look for a specific name inside a dictionary, and if this statement finds a name for the first time in the dictionary, then it assigns the value of 1 to that name. And if this statement has seen a specific word more than 1 time, then it just goes on and add 1 to the previous value of that name. Now another benefit this get method can give us is no traceback error. So it just goes on and print out a default value of 0 for an item that is not present inside the dictionary. Now we will just go ahead and replace this entire conditional section of the code with a get method statement and see whether the get method performs the task gracefully or not. So I will remove this section and I will write name of the dictionary, and then I will use square brackets and I will write the name which I am searching for in the specific iteration, and after that I will write equals, and after that I will write the name of the dictionary again, and then I will use the get method, and inside that get method I will write the name which I am searching for inside the dictionary, and then I will write the default value 0. So if the name is not present in the dictionary, then the get method will print out 0. But if it finds the name inside the dictionary, then it will add 1 to the previous value. So if the name occurs for the first time in the dictionary, then 1 will be added into 0, giving 1 in the result, which means that the word has occurred once in the dictionary. In the case of the name that is occurring again inside a dictionary, 1 will be added to the previous value, which is now 1. So 1 plus 1 will be 2, which tells us that the name in the dictionary has occurred twice. And that's how the entire loop goes on again and again until the entire dictionary has been processed. And in the next line, I am trying to print out the dictionary. I will save this program and I will run this program using Python. And you can see that all the names in the dictionary has occurred once, but John has occurred twice in the dictionary. Here you can see that we have John written 2 times inside a dictionary, and all the other names are written only once, which means that this get statement has successfully replaced the entire conditional section that we wrote earlier for the same program. In Python, we have multiple patterns through which we can perform counting tasks for dictionaries. So in lecture 5, we'll go ahead and study about these counting patterns. The general method, or it can also be known as pattern, to count the words in a line or sequence of line is to split that line into words and then loop through the words and use a dictionary to track the count of every word. Now for example, here I have written a small code for that. In the first line, a dictionary has been created using dict function. Now in the second line, the program is asking the user to enter the line of text as an input in runtime. And after that, input will be stored in a variable called line. Now the program has to split that line into words. So we will use split method for that. And at the last step, we have to loop through that data using for loop, and we will use get method to find out that how many times a word has been repeated in that line of text. Now here I have written the same exact code that we have just discussed. The first line is used to generate a dictionary, and the name of that dictionary is dict. And after that, we are asking the user to enter the input in the runtime, and then we are storing that input into a variable called line. Now we have to split that line using split method. Now after splitting that line, the data will be converted into words. Now we will use that for loop to iterate through those words. And for that I will use an iteration variable that will look in the list of words. Inside that loop, we will use a get method, and this get method will actually go ahead and count the number of times a word has been repeated in that input. After that, we'll go ahead and try to print out the entire dictionary that we will get after performing all this process. So I will save this file using Ctrl+S and I will run this program using Python. You can see that here the program is asking me to enter the line of text. So here I will type a random line. For example, I am a programmer. I love Python. I am making a course. I will hit enter and you can see that every word that is written inside the input has been splitted, and in the input you can see that I have written I 3 times. So in the dictionary I am getting I against 3, which means that I has occurred in the data 3 times. M was present 2 times. A was present 2 times. And programmer was present 1 time. And that is how it will count all the other words that are present in the output. We can use definite loops to iterate through dictionaries. Even though dictionaries are not stored in any order, we can still write a for loop that goes through all the entries in the dictionary. But that loop actually goes through all the keys in the dictionary and looks up the values. For example, here I have a dictionary, and after that I'll just go ahead and write the for loop that will iterate through the entire dictionary. So here I will use an iteration variable that is called key, which will actually go ahead and look for the labels that are present inside the dictionary. And in the body of that for loop, I will write print key, dict, square brackets key. Now here key actually refers to the labels of the entries that are present inside the dictionary, and dict key actually refers to the values that are stored against those specific labels. And in the output you can see that money 1, phone 23 and name 45 has been printed out. Here money is the label and 1 is its value, and again phone is the label and 23 is the value of that label. So that is how we can use definite loops to iterate through the dictionaries. We can retrieve the lists of labels and values from a certain dictionary. We can use different functions and methods to extract the keys, values, or items from the dictionary. Keys refers to the labels that are present inside a dictionary, and values are actually stored against their specific labels. And when we talk about items, we are actually talking about a complete key value pair. Now for example, here I have used a list function. A list function can actually go ahead and extract all the labels that are present inside a dictionary. And here you can see that in the output, money, phone and name has been printed out. We can also use keys method to extract the values from the dictionary. Here you can see that I have used dict.keys parentheses, and in the output you can see that all the values that were stored against their specific labels has been printed out. And we can go ahead and extract the items altogether from the dictionary, and we can use the items method to do that. Here you can see that I have used items method. A complete key value pair has been printed out. These pairs are actually called tuples. Tuples are another method that we can use to structure our data in Python. In chapter 10, we will study about these tuples in detail. At the end of this chapter, we'll go ahead and create a program that gracefully deals with the text files using Python. That program has to be able to extract the words from the file, and then it should count that how many times a word has been repeated in the file. Then at the end it has to print out the most repeated word along with number of times that it was repeated. So here are the steps that we need to follow in order to create this project. At the first step, the program has to ask the file name from the user in runtime. In the second step, the program should open that file. At the third step, the program should be able to extract lines from that file. And the next step, the program should be able to convert those lines into words. At step 5, the program have to save those words in the dictionary. After that, the program should be able to use get method to count how many times a word has been repeated. At step 7, the program should compare to see which word has been repeated the most, and in the result, the program should print out the most repeated word along with the number of times it was repeated. So in order to make this program, let's fire up our Visual Studio Code. Following step 1, the program should be able to ask the user to enter the file name. And for that, I'll go ahead and use input function, and in that function I will write a string which the user will see, which states enter the file name, and I will store its value in a variable called name. After that, I will try to open up that file using open function, and in the parentheses of this function I will write the variable name in which the file name has been stored, and I will assign this value to another variable called handle. Now you can control or manipulate this file through this handle variable. Now after that, I have to extract the lines from that file. So for that, I'll go ahead and define a loop, for loop, and then I will use an iteration variable which is line, and then I will ask this loop to look for lines in handle. And we know that in handle we have our file saved. What I want to do, after extracting those lines, I want to convert those lines into words. So I will use the variable name words, and I will use a split method to convert this line into words. Now because the parenthesis of split is empty, so this method will split the lines on the basis of white spaces in them. Now after that, what I want to do is converting these words into dictionary, and then I want to count through all these words. So for that, first of all, I have to generate a dictionary. I will suppose a variable, and then I will use the dict function to generate a dictionary. After that, I'll go ahead and write a loop that will iterate through all the words in the dictionary, and I will assign an iteration variable to that loop, which is word, and then I will ask this loop to look for the specific word in words, and this words variable contains all the words that we extracted from the file. Now inside that loop, I will write the get method. Now dict word actually relates those words to a dictionary, and then after that we will write an assignment sign, and after that we will ask get method to look inside that dictionary, and then that get method will look for words against default value 0, and in the next iteration it will add 1 to the previous default value. So in other words, this statement will actually give us the number of times each word has been repeated in the file. So for checking that, I'll just go ahead and print out the value of dict. I will save this file and I will run this program using Python. You can see that here the program is actually asking me to enter the file name. So I have already created a text file named as file.txt. I will hit enter, and you can see that it has converted the lines into words, and after that it has also counted that how many times a word has been repeated. And you can see that I is repeated 4 times, M is repeated 2 times, Talha is repeated 1 time, A is repeated 1 time, and just like that it has counted all the other words inside the file. Now what I actually want to do is print out the most repeated word along with the number of times that it was repeated. So for that, I'll just go ahead and comment up this line to disable it, and after that I'll define another variables which are called big count and big word. So big count actually refers to the highest count in the dictionary, and big word is actually that word which has been repeated the most. So initially I will assign both of them a value of none, which means before comparing all those words, these two variables contain the value none, and after that I will write a for loop that will iterate through the entire dictionary. And here you can see that we have labels and then we have values against those labels. So for that I'll just go ahead and use two iteration variables. The first one is word and the second one is count. So the variable count will look for the most counted value, and the variable word will look for the corresponding word to that highest counted value. And after that, I will use an in operator to ask this for loop to look, and after that I will use in operator, and then I will tell the for loop in which file that it has to actually look for. So I will write dict.items. So I am asking this loop to look for these two variables inside these items, and dict.items actually contains all the items that are stored in the dictionary in the form of label value format. After that, I will go ahead and add indentations, and in that loop I will define a conditional statement which states if big count is none. Now first of all, we have to understand this statement. Even before this loop executes, the reference value of big count is none. So when a word has not even been counted, then the value of big count will be 0. And that 0 is represented by none. If this condition is satisfied, or the next count in the iteration is greater than the reference big count, then assign that count to big count, which means update the value of big count to the new value of count, and also update the value of big word and assign big word a value of word which is stored against that highest count. And after that, I'll go ahead and print out big word and big count. I will save this program and I will run this program using Python. The program is asking again to enter the file name, which is file.txt. And here you can see that the program has given me an output of I4, which means I has been repeated for most of the time, which is 4. In other words, I has been repeated 4 times in the file. We can also update our print pattern, and we can write here word and then we can add highest count. We can save this program and we will run this using Python. We will enter the file name, which is file.txt, and here you can see that the highest count is 4 and the word I has that highest count. In chapter 10, we will learn about tuples in Python. We will see then how we can use these tuples to structure our data. A tuple is an ordered and immutable collection of objects, which means that inside a tuple, elements are arranged in an ordered manner. Tuples are sequences, just like a list. But there are two major differences between a tuple and a list. And the first difference is that tuple cannot be updated, which means that you cannot add, remove, or replace any element inside a tuple. And the second difference is tuples use parentheses, whereas lists use square brackets in order to contain its elements. For example, here I have written a tuple. I have used parentheses, and inside that parenthesis I have written elements. Words will be treated as strings, so they will be written inside quotation marks. But on the other hand, numbers don't need to be written inside quotation marks. Now earlier we said that tuples are ordered collection of data, which is exactly same like a string and a list. In other words, everything that is written inside a tuple is arranged in an ordered manner. Also, every element inside a tuple has a specific index number assigned to it. For example, here I have 3 names inside a tuple. So the very first name will have an index number of 0. The second name Walker will have index number 1. And third name Bob will have a specific index number 2. So what if I want to go ahead and call out a specific name from a tuple? Obviously, I will call the index number of that specific name. Here I have tried to print out the name corresponding to the first index number. And you can see that in the output, Walker has been printed out.
Up till this point, we have an understanding that tuples behaves exactly like strings. So we will see that whether we can update our tuples or not. Tuples are immutable, which means we cannot change or update the content of the tuple elements. Instead, we can take portions of existing tuples and we can create new tuples from there. Now, for example, here I have a tuple in which I have stored 3 elements against index numbers 0, 1, and 2 respectively. The second statement of the code actually wants to update the element which is saved against index number 0. And you can see that as a result, Python is giving us a traceback error. Because tuples are immutable, we cannot change the content of a tuple. This is exactly same like strings. Remember we said that strings are also immutable because you cannot change the content or character of a string. So if you ever try to change or update the content of a string, instead of doing that, the new string will override the previous string altogether. Just like strings and lists, we can perform concatenation of tuples. Here I have 2 tuples. In the first tuple, I have stored 3 numbers, and in the second tuple, I have stored 3 names. And in the third line of the code, I am doing concatenation. And after that, when I'll go ahead and print out the resulting tuple, you can see in the output, you will have the elements of both tuples inside this new tuple. So that is how we can perform concatenation inside tuples. Now we need to understand that what are the basic tuple operations that we can perform in our Python program. Just like lists and strings, len function is used to find the number of items in tuples. So you have to remember that tuples are actually the combination of strings and lists. In some ways, they match with the properties of strings, and in the other ways, they match with the properties of the list. But just like strings and the list, we can also find the length of the tuple using len function. We can also perform repetitions in tuples. In other words, we can write loops, and those loops will iterate through all the elements that are present inside that tuple. And same as previous structures that we discussed, like strings and lists, we can also use in operator inside tuple. Now this in operator reduces a lot of code because it does the same exact task that a complete loop which consists on multiple lines does. I will suppose a variable x, and in that variable I will assign a tuple that contains multiple elements inside it. And after that, I'll just go ahead and try the in operator for that specific tuple. So I will check whether 23 is present in the tuple or not. So I will write 23 and then I will type out in operator, and after that I will write the name of the tuple, which is x, and I will execute this program, and you can see that the Python returned the answer as true, which means that 23 is actually present inside our tuple. Now I will try this in operator for such number that is not present in our tuple. For example, so I will write 400 in X, and you can see that it returned the answer as false because 400 is not present in our list. And that is how we can use in operator instead of writing the complete loops that will iterate through all the elements in a tuple to see whether a number is present in the tuple or not. We will move ahead and study about the indexing and slicing in tuples. We know that the tuples are ordered set of collection, just like strings and list, which means that in order to save an element inside a tuple, we have to assign an index to that element. Now, because tuples are also sequences, that is why indexing and slicing work the same way for tuples as they do for strings. For example, here in a tuple I have three names. The first one is John, second one is Walker, and the third one is Bob. Now, three indexes have to be assigned to these three names, and they are as follows: 0, 1, and 2. Now, what if I want to call out a specific name from that tuple? Now, for that, I have to call its index number. And just like here, I have called the element which is stored against 2 Now, we can also use negative indexing in tuples. In the positive indexing, the counting starts from the left, which means that John will have 0 index, Walker will have 1 index, and Bob will have 2 index numbers. But as soon as we use negative indexing, then the counting starts from right, which means that Bob will be 0, Walker will be 1, and John will be 2. So in this case, instead of printing out Bob, the Python will print out John. Now we can also perform slicing to these tuples, and the slicing method is exactly same like lists and strings, because all of these data structures are ordered and they have assigned a specific index numbers to the elements in a tuple. So to slice down a tuple, I have to use a slicer, and for that I will use a colon operator enclosed in a square bracket. At the either side of this colon operator, the starting and the ending point of the slicing will be written. Here I have 1 on the left hand side of colon, which means that the slicing should start from the element which is saved against index number 1. And on the right hand side, we don't have any number at all, which means that we have to slice down the tuple until the very end. Now this slicing will start from the element that is saved against index number 1, and it will end at the very end of the tuple because there is no ending point defined in the slicer. So as a result, Walker and Bob will be printed out. So this method of slicing is exactly same as list and strings.
Hello everyone, I am Mutable, and today we are going to start a brand new series on object-oriented programming using Python. But before diving deep into OOP, we have to understand a basic concepts related to classes and objects. We have to understand that what is a class and what is an object. But before even understanding this, we have to familiarize with a couple of different terminologies that will help us along the way. So the very first terminology that we have to understand is class itself. So we can just to understand that what is class, we can refer it as a blueprint or a design. Now moving forward in this series, I will explain that why we call this class as blueprint or design, but for now let's just go with the flow, right? Now similarly, we have something called object, and to understand that what is an object, we can refer to it as a real world entity. Now this entity can be anything. It can be a laptop, mobile device, food, a piece of clothing, or a human itself even. Now previously in procedural programming, we have been using something called functions to perform certain tasks, right? Now the same functions when written inside a class are known as methods, and we use those methods to perform different tasks. Now when we talk about objects, we have two things that define those objects. The first one is called attributes and the second one is called behaviors. Now when we talk about attributes, these attributes are called properties. We can also refer it as a data that will define an object. It can be name of a person, it can be height of a person, it can be RAM of a laptop or a hard disk drive of a laptop. And the second one is behavior. Now behaviors are something we can refer to as actions or work. So we define our objects using attributes, and based on those attributes our objects do something. Now that function is called behavior. So let's just go ahead and use a couple of different examples to understand that what is an object. Now even in our daily life we use objects to perform different tasks, right? For example, if I want to record a video, I'm gonna need a couple of things like camera or video editor at least. Now these both things are called objects. For example, if I want to eat something, then I'm gonna need some utensils for it. For example, I'm gonna need a plate, spoon and glass, and all of these things are objects, right? Now we use these objects to perform certain tasks. We use a camera to record a video, and recording a video is something that we can call a behavior. We can use a glass to drink. Now that glass will be used to store some water, so that can be an action or something that is called behavior for this object. Let's build up a better understanding of an object, right? For example, here we have this a very funny looking cartoon character called Jerry from Tom and Jerry. Now this is something that I can call an object. Now this object have two things. The first one is attribute and the second one is behavior. Now the attributes is something that will define this object. For example, we can give a name to this character. For example, we can call it Jerry, and we can also define its height. Now we will give this data to this object using variables. So we can also say that these attributes are called variables. Now based on these variables and based on this data, this Jerry will do something. For example, it will laugh, it will run, it will jump, or it will do something else. Now that action is called behavior, and to perform that behavior, to do that behavior, we will use something called methods, and those methods are simply nothing else but functions. Moving forward, whenever we talk about objects, we also talk about class. But why class? I mean, as far as object is concerned, we have built a little bit of concept that what is object and why do we need it. But why class? So let's take another example of an object here. In this case, we have an object called laptop. For example, this laptop is made up by Samsung. And this is a new laptop that just had been released in the market, right? Now there will be millions and billions of different laptops of the same model in the market, but all of those laptops will be based on a single design. So we use a single design to create multiple objects. So just like that, in a software world, we also use a design that is called a class to generate multiple objects to perform multiple tasks. So I hope by now you have a little bit of concept that what is class and what is object and why do we need class and objects. We will create a structure and a design of a software, and then we will create objects or instances of that class to perform several tasks. Now in the coming tutorials, it will be completely clear what I mean by creating multiple objects to perform different tasks. So just stay tuned and don't forget to see the coming tutorials. Hello everyone, welcome to this second tutorial of object-oriented programming using Python. And in this video we are going to learn that how we can create a class and methods inside of that class using Python programming language, and how we can execute them in our Visual Studio Code. So this is the I have created a file named class.py using my Visual Studio Code. This is my Vscode, and here I will create a class, and inside of that class I will place a method, and using that method I will try to print several different outputs to understand the working of class and functions and methods. And while defining all that, I will use objects to print out my answers. So let's dive into this video. So let's just go ahead, and I want to create a class. I will create a class named as person, and here you can see the color of the text has been changed. Okay, so first of all, what I will do is just create a simple class, and then I will create a simple method inside of that class to see the working of or to understand the syntax of class and methods and objects. Okay, so inside of this class, what I will do, I'll just go ahead and I will write define, and I'll create a simple function like we used to create in our procedural programming. So I will just go ahead and let's say I will write test function, and when we create function we write self into it, and I will just explain that why we add self here. So let's just go ahead and print something here. This is my test method in person class. Okay, so what I'll do, I'll just go ahead and create an object for this class. And what I mean to say is what I'll do, I'll just create output. Let's say I will create a variable output, and I will assign it person parenthesis. So right now what I did, I called my class and I assigned that value to this output here. So if I'll just go ahead and let's say I'll just try to print out the type of this variable. So so we understand that if it has become an object or not, and I will execute this, and here you can see the type of this output. It says that it is a class and it belongs to this person class. So here we can see that our output has become an object of this person class. Okay, so what I'll do, I'll just go ahead and comment this out because we don't need it anymore. What I want to do is after creating this object, I want to let's say I want to print out my this value, this statement right here. So in order to print out this, I have to call my method this. So if I'll just go ahead and I will write print test, if I'll just go ahead and let's say if I remove this print, you can see it's giving me an error because the program actually finding it hard to understand that where this test came from. It's not a global function, right? It is present inside of this class. Okay, so if we go outside of this class and we call this function, obviously it's going to show us some error, right? So what we will do, we'll just go ahead and let's say we will call our class, and we will use dot, and you can see the output has or the error has been removed from here, because now program knows that from this class we have to call this test function, right? So what we will do is we will give it the value of this object. We want to print out this, so what I'll do, I'll just go ahead and give it to this function. Now you can see that this is what you are giving to this function. So this is the attribute that you are giving to this test function inside of this class. So to store this object, here we are using an argument called self, right? So what if I'll just go ahead and I will save this file and I will return this file. So you can see the output of this test function has been printed out, right? So that's what our self actually does. It takes our object and put it inside of this argument here. So let's just go ahead. I mean, we honestly will not see much of this statement in our coding. What we are going to say is it's gonna be like output dot test, right? So what we are doing is we are using an object that we just created, and inside of this object you can see this object actually contains our class, right? So inside of this object we are calling the test function. So this actually works the exact same way like this, right? So it will give us the exact same output like this statement here. So you can simply think of it like that it is another way of writing this statement on the line number 10th. So what we are doing is, instead of giving this object inside of parenthesis of this test function, we are actually giving this by using this dot method, right? So what we are doing is we are just using this object to call this method. It will again use this object as an attribute for this argument. So in this self, again this object will be stored like in the previous line here we did. So if I'll just go ahead and if I'll save this file, and if I'll go ahead and run this file, you can see the output is exactly the same, right? So what I will do, I'll just go ahead and uncomment this, and I will save this file, and I will clear this command prompt, and I will run this program again to see if both statements works equally or not. So here you can see the output of both of these lines is exactly the same. So either you can use this notation or you can use this notation, and obviously you won't see much of this form in your coding, or generally in Python coding. What you will see is this type of coding, right? So this is a simplest class and object and method that we can create using a Python. Hello everyone, welcome back to this object-oriented Python programming series using Python, and in this video we will learn that how we can use init method inside a class to initialize the variables. So I hope you remember that in the first video I explained that we have to define an object in order to use it in our software or in our program, and I explained that there are two things that will define an object, and one of them is attributes. So we call those attributes as variables. So these are the variables which hold the data that later on define an object, right? So what I will do, I have written this class and this one method just like in the previous video, a previous example that we discussed. And what I will do, I'll just go ahead and I will create an object called out1, and in that object I will store my class. Don't worry about these errors, we will just take a look at them after we have completed our code, right? So what I want to do is this time I want to use attributes to define my methods, right? So let's say I want to give a value to this class or this object, and I want to use that value inside this method. So for that, what I have to do is I have to initialize a variable that will hold the value that I will enter here, right? So I'll just go ahead and I will write def and double underscore init, and here you can see I have a couple of different suggestions. I'll just go ahead and click here, and here you can see a complete method has been printed out. I'll just go ahead and I will remove this just to keep it simple. Oops, okay, and here I will define the variable that will store the value that I will give here. So for example, I want to give 45 here. Okay, so this means that this object that I have created, it will operate on this value, right? and based on this value it will perform whatever that is written here in the body of these methods. So I have given 45 to this class or this out1 object, and similarly I have to provide a variable to this class that will store this 45 in it before processing, right? So for that I'll just go ahead and I will use a variable here that's called number, right? So previously when we were discussing about the objects and how we can call a method using an object, for example, if I just go ahead and write here output1 dot test, and I will write here, that means this output1 will be an argument to this test method inside of this person class, right? In the previous video I told you that this output1 is actually a parameter or an attribute that we give to this test method, and that is stored inside this self argument here. So similarly, that means when we talk about methods and classes, then we have to use this self. So similarly, if we talk about this number right here, this value right here, and when we define an argument inside of our class, then we, in order to store that that value in a variable, when we initialize a variable, we have to use self. So for that, what we can do is we can create self and dot, and here you can write whatever name that you want to give to your variable. For example, I want to give number 1, and you will assign this number to this variable. So this argument that you use to capture this 45, you will assign that number to this self dot num1. Now this variable will be used in this entire class in any method that you want, right? So for example, if I just go ahead and here I write print, let's say the number is, and here I can give self dot number, right? It's a slight difference. The class is person with small p, so I can just go ahead and here change it, right? Change it accordingly. So what it will do when you will call this object or when you will call this test function from this object, and you have given this object a value, this value will be stored in this number, and this object will be given to this argument, and the value 45 will be stored in it, and that will be supplied to this self dot num1, and afterwards we will use this variable to print out our value 45. So if I'll just go ahead and if I will print out or execute my Python program, here you can see we have an error. So what is this error? Yeah, we had to write this variable here, so I mistakenly wrote number. So again, save it and run it, and here you can see the output, the number is 45, has been printed out. Okay, so that means that's how this initialization method works. We use this init method to initialize our variables. So it works exactly same like constructor in other programming languages like C#, C++, and Java, right? So you can think of it as another constructor that we use in our classes. So remember, in the first video I said that we use classes as a design or as a blueprint, and using that design or blueprint we create multiple objects to perform different tasks. So here we can just go ahead and create another object. We can call that out2, and again I will call my class, and this time I will give it a value of Talha, let's say, let's stick to the integers. Let's give it 100, and here you will call your test method using your second object, right? Okay, so I'll just go ahead and let's say I clear out this prompt and I run this program. So here you can see this object is out1 printed 45 and this object printed 100, and for both of these objects we used a same design or same blueprint that is called this class. So that's how classes, objects and methods work. So that's what actually means when I said that we use a single structure, a single design or single blueprint to create multiple objects that will perform different tasks. Here we have used a very simple example by giving different integer values, but in complex examples it works exactly the same way. Hello everyone, welcome back to this object-oriented programming with Python series, and in this video we are going to get deeper inside our classes and we will understand that what is the function of constructor and what role does self plays inside our objects. We will also discuss that how our objects take space in our heap memory of the computer, and we will also discuss that what is the ultimate thing that defines the size of our class. So without further ado, let's just dive into this video. So before we get to any of the things that I said earlier, what we have to understand is that how our init function actually works. We discussed it in the previous video, and we wrote a simple init function inside of a class, and we use that function in order to process our other method inside of a class, right? But there's something that we have to discuss about init itself. So for that, what I can do is I can simply write a simple class and I can name it as computer, and inside of this class I can write my init function, and I'll just simply go ahead and remove this, and I can write another method and we can call it a test method, and I will again give it self, and here I will write print. This is second method, right? And what can I do is I can simply go outside and I will create an object named as C1, and I will call my object here. So right now we have created our object, we have created a class, and inside of our class we have created an init method, and then we have created a test method right here. But the thing that we have to discuss here is init method, right? So I mean, we all know that whatever we write in this function, it gets used in other methods inside of a class, right? So whenever we call a class, this method automatically gets processed. What I mean to say is I can simply go ahead and I can write print, this is my first class. I can simply remove this space and I can save this file and I can run my program again, .py, and here you can see when I ran my constructor.py and I just created an object, you can see this line has been printed out. This is my first class. So you can see I didn't call any method. I didn't ask this class to do anything. So I simply called my object of this class here. So when I called my object, this method has been processed automatically. And because in this method we had this print function, that is why this line has been printed out, right? So if I can just go ahead and I can write C1 dot and I can call my test method here, and I will save my program and I can write Python constructor again, and Here you can see the very first thing that has been processed is init method itself. So the first line, this is my first class, has been printed out, and after that what we call our second method, this is a second method that has been printed out. So that means whenever we call our class, this init method gets processed automatically, right? So this, in other words, this function runs automatically. But the question is why this init method gets processed automatically. I mean, what is the need of this? So obviously this method contains a couple of different variables, right? So let's just say I mean, I had a variable here. I will not write the actual variables. I will just use a pseudocode. For example, I will use a RAM here. Let's say it's a 30, and I can say disk here. It is let's say 512. Now, if I want to, I mean, in this second test method, I want to print out those variables, so I can say this is the property of my laptop, right? And here I can write RAM and disk. So whatever that has been stored in these variables will be printed out here. Don't worry about these errors here because we didn't use self, that is why it's showing error. But right now we are just talking about the concept that why this init method gets processed automatically. So let's just say we call this test function from this object, and suppose this method doesn't gets processed itself. That means we will not have any values inside of these variables, and if that's so, that means we will not have any values to print here, and in that case our test method will give us error, right? So to prevent that error, everything that has been present in our init method is processed automatically, because in the later stages all of those things that are written inside this init method will be processed or will be used inside other methods of the class. So that is the ultimate reason that why init methods is actually processed automatically whenever we call the object of the class. Okay, with that being said, now we will move forward with our today's topic of the video, which is let's just talk about the heap memory first. So whenever we call our function or whenever we create an object of a class, this object occupies some space inside the heap memory of a computer. And let's just say we want to see that what is the location of that object. So I can just simply go ahead and remove all of this, and for the time being I can write pass here. Alright, so for now this is a simple class. It has nothing inside it, just this pass keyword, and I can simply go ahead and remove this, and here I have created the object of this class, right? So I will click I will clear this prompt, and what will I do? I will use id function to see the location of this object inside of the heap memory of my laptop. So I can write print id c1. So this id function will actually give us the location in the heap memory. So I can simply go ahead and here you can see this c1 object is saved at this place inside the heap memory of my computer. So simply if I just go ahead and create another object and I print the ID of that object, then you can see both of these objects have been saved in different locations. That means these two objects are two different things, right? So if I just go ahead and I simply write, let's say init method, okay, okay, let's say inside it I will write self dot disk, same variables that we used earlier, 30, and self dot ram is equal to 512. Okay, for the time being, just don't worry about this self. I will explain that why I'm using this self here, or what is the need of self inside of a class or inside the methods of a class, right? what role does it play, and why it is so necessary that without it our class or objects will give us errors, right? So don't worry about it. Let's just go with the flow right now. Okay, so I just used these two variables, and what I can do is I can create another method, and I can call it, let's say, present, right, to present the characteristics of my laptop, and I will again give self to it. Let's just say I will write inside the body of this method print the properties of my laptops. My laptop are, and here I can write self.ram and self.disk. Okay, so if I just go ahead and if I will write c1 dot, and inside of this object I will call present, and c2, and I will again call present. And if I just go ahead and save this file and clear this prompt, and run this program. This is embarrassing. Okay, we have this little error here. We made a little spelling mistake. Again, clearing the prompt and run this program. Here you can see the value or the output of both of these objects is exactly the same. The property of my laptop are 5, 12 and 30. But we know, if I'll just go ahead and again print the IDs of these two objects, we will realize that even though the output of these objects is same, the location of these two objects is actually different, right? That means these two are different objects. But right now, because we gave same values to both of these objects, that's why they are yielding in same output, right? But let's say I want to change the value of my first object. So I can simply write c1 dot disk, because I want to change the value of this disk. Let's say I am giving the value of disk is 120, and I am giving the value of RAM as, let's say, 1000. So if I will save this program now, and if I will run this program, here you can see the values of C1 object has been changed or updated. So now you can see that these two objects are actually two different things that will be used to perform two different tasks, right? So now let's just move ahead and see that what is the role of this self. Okay, so all of this that these values have been stored inside of our this init method, and this init method is actually what we call as constructor. Okay, constructor, right? So that means you can say it in these words that the building blocks of entire class will be defined in this section. And that is why this section is called constructor, because it will construct all of things that are yet to come in other methods of our computer class, right? So this is called constructor. But what is self? Why are we actually using self, right? So I'll just simply go ahead and I will, let's say, remove this. Okay, so what I want is I want to call my this present method. So I can call my computer class, and from this class I can call present, and what I can say now, I will give the value of the object that I want to work on, right? So I will, let's say I want to work on C1, so I will give C1 this. So this C1 will be saved inside this self argument, right? So after that we feed this C1 to this self, C1 is saved in it. That means it will become c1.disk and it will become c1.ram. And that C1 will also be transported to this self as well, right? and because of that we had, I mean, for example, it became c1.disk and it became c1.ram. So similarly, it will become c1.ram and it will become c1.disk, right? So basically, this self keyword is actually used to point towards the object that we are going to work on, right? I mean, whatever object that we are going to use, that will be solved, or that means whatever object that we are going to work on will be stored inside of this self keyword, and that keyword will be used in all the methods inside our class, right? So this self is actually defines that, okay, I mean, this function is identical to every object, but this self tells this method that you have to work on that certain object, right? And we can simply just go ahead and write this into a new notation, and we can call that c1 present this. Now this means exactly same as this, right? It means that we are calling a class and we are calling a present method inside of that class, and after that we are feeding that method this object c1, and we are asking our class to work on this object, right? So if I'll just go ahead and if I will use c2 dot present, I can save this program and I will comment this line here, and here you can see that the value of a c1 object and c2 object has been printed out. So just to summarize, that this init method is a constructor that will hold all the building blocks that are going to use in all the other methods inside our computer class or any other class that we will create. And when it comes to self, self is a keyword that actually points towards the object that we are going to use inside our object or inside our class, right? So whatever object that we will work on, it will be stored in this self, and because it will be stored in this self, then all these variables will refer to that object, and all these variables will be related to that certain object c1. Now what if we want to compare two different objects? What we will do, or how can we do it? For that, we can simply just go ahead and write another method. Let's just call it compare. Now because we want to compare two different objects, so the first one is going to be stored in self, obviously, and the second one will be stored in another argument. We can name it as second object. Okay, so let's say I want to compare these c1 and c2 based on the value of this disk, right? So I can simply write if self dot disk is equal to second object dot disk, because c1 will be stored in self and c2 with whom we want to compare our c1 will be stored in second object, right? So we are simply saying if c1 dot disk is equal to c2 dot disk, then return true, else return false. Okay, so if this function will return true, then what will happen is we can simply write another statement here. We can say if c1 dot present c2, if this exists, in other words, if this is true, then just simply print they have same values. Else just print they have different values. I'll just go ahead and save this file, and I will simply exit this. Okay, clear. cd desktop. Let's just go to the folder where all of this has been saved. Okay, and here we'll simply write a command to run this program, constructor.py. Okay, we have some error. Oh, sorry, because we want to compare, we had to use compare method. So we are simply just calling present method again. Here we will write compare method. I will save this file and I will run this program again. So here you can see it's saying that they have two different values, because in C1 we have disk 120, and because we didn't change the value for C2, then C2 has the value of disk as 30. Let's just say I will remove these two lines. That means C1 has value of disk as 30 and C2 also has the value of disk as 30. I will save this program. I will clear my prompt and run this program again. And here you can see it says that they have same values. So that's how you can compare your objects in OOPS using Python. Hello everyone, welcome back to this object-oriented programming with Python series, and in this video we are going to learn that what are the types of methods in object-oriented programming using Python. So without further ado, let's just dive into this video. So when we talk about the types of methods in OOP, there are three common methods that we can think of. The first one is called instance method. The second one is called class method, and the third one is called static method. Now here we have to pay attention because when we talked about variables, we said that class and static variables are the same thing, but it's not the same in the case of methods. When we talk about methods, class methods and static methods are two different things. So always keep that in mind when we work with methods. Now we have subcategories or subtypes of instant methods, and they are called accessors and mutators. So we will go deep in the types of methods, and we will implement each of these methods one by one, and we'll understand that how these methods actually work when it comes to classes and objects. So just like every other video, we'll create a very simple class and we'll call it computer, and then inside it we will create an init function which is called a constructor, and inside this constructor we will just create a couple of variables. Let's say we are talking about computers, then again we'll take a RAM, and let's just take the values from the user while calling the objects, right? So in that case we will have to give variables here. So we can say RAM, we can say hard, and let's say we also say like keyboard. Okay, so we'll say the third entity is a keyboard. Okay, so for that when we will call RAM, we will use self.ram to store that value, and similarly for hard we will say self.hard. You can obviously you can assign any variable that you want. These are just random names, and we can say keyboards, and we assign it the value of keyboard, right? So let's say I create a method, and through this method I want to know the characteristics of my laptop, right? I want to see that how much RAM it has and how much hard it has. So for that we will create a method, and we'll say status, and we will use self like we use every time, and this time we will say the properties of my laptop are, and we can say self dot ram, and we can say self dot hard. Okay, so what I'll do, I'll just go ahead and I will create an object called c1, and I will use computer parentheses, and inside these parentheses I will give the values for these three variables that we just created. So I'll say my RAM is 512, my hard is 2000, and keyboard is yes. Let's say I will say yes. Okay, so what I will do, I'll just go ahead and I will just to test if this function is working, or if this method is working right or not. We'll just go ahead and we will write ram c1 dot hard and c1 dot keyboard. Right, so what we'll do, we'll just go ahead and save this program, and we will run this program. So here you can see the value of RAM and the value of hard and the value of keyboard has been printed out. Now we are talking about instance methods, right? So in the previous video we said, when we talked about instant variables, we said that the variables that are written inside this constructor are called instance variables. Okay, so right now what we have done so far is, first of all, we are talking about instance methods, right? Okay, if we reflect back to the previous video about types of variables, in that video we discussed about instance variables, and we said that every variable that we create inside this constructor is called instance variable, right? So every method that will use those instance variables will be called instance method. Like right now, in our status method, we are using self.ram and self.hard, and these variables are called instant variables, right? So because of this status method is called instance method, and you can also recognize instance methods by this self keyword. Every method that will have self keyword in it will be called instance methods, right? So first of all, now we know that what are instance methods, but we also have to understand that what are accesses and what are mutators, right? And these are the subtypes of instance methods. So accesses, as its name suggests, these are the methods that access things, that get things, right? So for example, if I'll just go ahead and I will write, let's say define get ramp. Let's say I create this variable and I will use this self, and I will write print. I'll say the RAM of my laptop is, and I will say self.ram, right? Now in that case, when I will just go ahead and I will call my object, and I will, from that object I will call get RAM, and I will save this file and I will run this program again. You can see the RAM of C1 has been printed out, right? So what this method actually did is accessed the value of this RAM of this C1 object, right? And now you can also see this self has been used in this method. So in a way it is still an instance method, but at the same time it's getting a value, and it's getting a value of RAM. So that is why we can also call it a getter, or we can also call it an accessor, right? And similarly we also have mutators. So mutator comes from the word mutation, and mutation means change. So the methods that can change the value of a certain variable or we should say a method that can change the value of an instance variable is called a mutator, right? So what we can do is we can just go ahead and we can say set RAM. We can also call these methods as setters. So again we will use this self, and because now we have to set a value, then that's why we have to get another value, and for that we have to write an argument here, right? So here we can say or we can say that self.ram is equal to this value, and then we can say print the RAM of my laptop, right? And here we can say self.ram, and when we will call this method, we will say c1.setRam. Now here we will give the value because we added an argument here. So for example, I will just go ahead and I will write 4000 here, and I will save this file and will clear this prompt, and here I will run my program, and here you can see before the value of my RAM was 512, right? But then what I did, I called my set RAM, and through this method I changed the value of my RAM from 512 to 4000. So because it set a new value, that's why we can call this method as a setter, or we can also call it as a mutator. And you can see here we are again using this self keyword, and that's why it's still an instance method, right? So that's about it about instance methods, and we also discussed what are accessors and what are mutators. Now let's just move forward toward class methods, right? So in the previous video we talked about class variables, right? So those were the variables that were written outside this constructor and inside this class, right about here. I mean, in short, the methods that will use instance variables will be called instance methods, and the methods that will use the class variables will be called class methods. So what I'll do, I'll just go ahead and I will create a class variable here. Let's say I will create a variable brand, just like in the previous video, and I will use this as del, right? So what we can do here is we can create a method that will use this class variable. So what we can write is we can say define, and we can say brand. This is the name of the method that we will create, and now here instead of using self we will write CLS. CLS represents class, right? So it makes, or it turns this method from instance method to class method. So what we'll do, we'll just go ahead and let's say I will write here the brand of my laptop is, and here we can say brand, right? And just like we use self.ram, here we have to use cls.ram. Okay, and what we will do, we'll just go here and I will say c1 dot brand, and I will call this, and I will save this file and I will run this program. Okay, so here we have this error here. So I mean, what we have to do is we have to feed this method or class, and just like I mean in the previous video we understood this notation, right? We called our class, and from that class we called our method, and in this method we gave our object, right? So what this error is actually telling us is to do that for our class method, but we don't want to do that. We don't want to feed our class A between these parentheses. We want to write it just like this, right? So there's a way that we can use to avoid that previous notation, right? What we can do is we can just go here and use this @ and here you can tell your program that whatever is under this notation or keyword that you're going to write, whatever there is, it is a class method. So you can just write here class method. Right, so you can save this program, and hopefully when you run it, okay, so this is the error that this is the mistake that we are making. This brand is actually a class method, but we are using our object to call it. What we want to do is we want to write computer here. We want to write a class to call this class method. Now if you just save this program and run it, hopefully it will work. Okay, yeah, here this is the mistake. I mean, we actually use the same keyword for our method and same word for our variable. So we have to differentiate this because Python is getting confused at which one it has to consider, right? So we'll just change this method name from brand to branding, and we'll just change this again, and we will save it and we will run it. And here you can see your class variable has been printed out, which is del, right? So here goes our class method as well. Now we have a third type of the method, and which is called static method. So just to summarize whatever we have discussed until now is the first type of the method is instance method, and these are the methods that used instance variables. Then we had class methods, and these are the methods that used class variables. Now we have static methods. Now in the case of static methods, we don't use any kind of variables. We do not use instance variables, we do not use class variables, we do not use any kind of variables. These are the type of the type of methods that give you a static output. Let's say you have to print out something again and again in your program, and instead of just writing your print function and the statement again and again, you create a single method, and whenever you want that statement, you just call that function here. So in that case you use static methods. So let's just go ahead and create a static method. I'll just write here and I will say let's say I will say info. So here I can write print the laptop condition is good, right? So this what we have created here is called a static method, right? And just like class method, you also have to define your static method here. So you will write static method, right? This will create your info method into static method. Now whenever you want to call your method, you can just simply call it using your object. You can say c1.info, and I will save this program and I will run this program, and you can see that the laptop condition is good has been printed out. And here what you have to focus on is that neither we are using self keyword nor we are using CLC class keyword, right? So in the case of static methods, we do not use any kind of keywords here because we are not using any kind of variables here, right? We are not using instance variables or we are not using class variables. That's why these parentheses always stay empty. So that's about it regarding types of methods in OOP. Programming with Python series, and in this video we are going to learn about inner classes. And first we will just dive right into the code, and we will learn that how we can create inner classes inside a parent class, and then after that we'll discuss that why do we need inner classes in the first place. So first of all, let's just go ahead and create a class quickly. So we'll just in the previous videos we were talking about computers, so let's just create a computer class. And inside this class, I will just create a constructor which is called init method. And inside this method, I will take two arguments. So let's say, just like in the previous videos, the first argument will be space, and the second argument will be RAM. So I'll just go ahead and create my uh, variables inside this method for this certain class, and I will say, let's say self.disk is equal to space. So it will show the space of the hard disk of your computer. And in the next variable, I will just go ahead and save it as a RAM. So your RAM will be stored in this. So what I'll do, I'll just go ahead and simply create a function called show, and this function will just print out um, the value of my disk and the value of RAM. And after that, I'll just go outside this class, and here I will create an object. I will call it S1, let's say, and I will call my class, and this is my object. And from this object, I will call my function show. But before running this program, I'll just go ahead and give variables or the values or the arguments to my object. So, for example, I'll say that S1 object will have a disk space of 512 and a RAM of 16 GB or 16 GB. Right, so I'll just go ahead and save this program, and I will run this program using my Python 3. I'm using Ubuntu, so I'm writing Python 3 here, but if you're doing this on Windows, you can just write simple Python here. So just go ahead and run this program, and here you can see 512 and 16 has been printed out because these are the values of the disk and RAM that we gave to our class, right? So up till this point, this is just a simple class, right? I mean, it has it has nothing special. It's just same like the previous videos, right? So let's say that I want to create another class inside my outer class, which is called computer. Let's say I want to create a class called specs, and in this class, what I want to store is the brand and the CPU of the computers, right? So for that, I'll just go ahead and simply do that again. My init constructor for this class, and I'll just go here and I will write self dot brand, and here let's say I give it a brand name Dell. And similarly, I'll just give it a CPU of, let's say, i5. And I will write another method, and let's just call it show again. And we will print out the value of brand and the value of CPU. Right. So what we want is that, I mean, we have created this specs class inside of our outer class, which is called computer. Let me just go ahead and uh, reduce this window so we can see all of our code together. So this class is inside this outer class, right? So whenever we will create an object of this class, if we want to find the specs of that object, we can just call this specs class from that object. So simply, what we have to do is in this object we have to call our class that we saved inside this, right? So what I can say is let's say we create another object, and in this object we will call our first object, and from that we will call our specs, right? And this is called our I mean inner class. We have created a new object with this inner class. So in S1 we have this computer. So basically we are asking our code go inside this outer class computer, and then inside of that class find another object which is called specs, and which is related to this inner class that we have created. So I'll simply just go ahead and I will write s2 show. So now we have this second object of this inner class, and from this second object we are just calling the show function, which is this function. So let's just go ahead and save this, and let's try to run this program and see if it runs. So here you can see the first line is the show method from your first object, which was in your uh, outer class, right? So it just printed out the disk space and RAM, which is 5, 12, and 16. But the second show is related to your S2 second object, right? And this second object is related to this inner class specs. So that's why when you call show inside of, uh, I mean, from this object, then this method is being called. And here you can see the brand and the CPU has been, uh, I would say, printed out, right? And you can see Dell and i5 has been printed out. So what if we just, want to use other methods inside this inner class like setters or accessors, right? So let's just go ahead and create a setter. So I'll just call this setter, and I will give it self, and with self I will give it a new value that we want to set to the variable, right? So let's just say I want to change the brand name, right? So I will just call self.brand, and I will give it to the new value, this. And after that, what I want to do is I just want to call my show function again, right? So here what I can do is I can simply call s2, and from this object which is related to your inner class, I want to call my setter, and in this setter I want to give a new value to my brand. So let's say I want to change my brand from Dell to HP. So I'll just go ahead and I will save this program and I will run this program. And here you can see in the first line, this is just, this s1.show, which is giving us the value of disk and RAM. The second line gives us the values from the inner class. So it's printing out the brand and a CPU. But the third line, here we are setting the new value of the brand in the inner class, right? So what was Dell earlier, now it has been changed from Dell to HP, and we can see that here in the third line we have HP and i5. So that's how inner classes actually work, and that's how you can create inner class inside of an outer class. So basically, one might say that whatever we have done so far right here, it can also be done by, creating a separate class. So of course, that's completely correct. You can do all this by creating an outer class. A separate class. But sometimes when you're writing a code, what you want, you will have tasks that only wants to be repeated inside a certain class. For example, if we are talking about these specs, whenever I'm talking about computers, I only need specs in that time. If I'm talking about students, if I'm talking about let's say mobile phones, then I don't need these specs, right? So instead of making a new separate file for or new separate class for these specs, what we do is we just create a simple inner class inside this computer, because we know that we only will use this class when we're talking about computers. So that's why we are, generally we use inner classes inside of a parent class. So I hope you have learned by now that how we can create inner classes inside of our parent class, right? So yeah, that's it for this video. Hello everyone, welcome back to this object-oriented programming with Python series, and in this video we are going to learn about inheritance, then what is inheritance and how we can create it in Python programming. So the word inheritance itself describes everything. I mean, just like in real life, if we talk about father-son relationship, so it's exactly like that. I mean, for example, this is my laptop on which I'm recording this video, right? So this is my laptop. But if my father has a laptop, then that laptop is also mine. I mean, if my father has a piece of land, then that land is also mine. So this is exactly the concept that we can also implement in our coding. So what I mean to say is, for example, this is a class, and call it brand. This is a brand class, and I will just simply create a class in it called uh, company. Sorry, a method in it, not a class. It will be called self, and here I can print del. Right. So this is my one class. Let's create another method, and we can call it specs, and we can say itself, and here we can print, let's say i5 512 GB of hard and 16 GB of RAM. Right. So what I mean, if I just go ahead and simply create an object, I can call it b1, because we have brand. We can create an object here, and if we just go ahead and call uh, our object, now in this object you can see the list of the methods that we have in this object. Like we have company and we have specs. This is a company and this is called specs, right? So if we just save it, and if we just run this program, you can see the brand or the company name of my laptop has been printed out, right? So Dell is printed here. So what if I just after some time I'm creating an app and I create another class, let's say, and I will call it computer. Now what I want to do is I want to give all these methods to this computer class. So the one way is just copy here and go here and paste it. But in real life, we will be dealing with hundreds of lines of code, and this is not an optimal way, and it is not desired or liked in a professional manner. So how we can bring all these methods to this computer class? We can do this by inheritance. What we can do is just go ahead and write brand in the parentheses. Just by doing this, we are giving this entire class or all the methods in this class to this new class, which is called computer. And if I just go ahead and create a new method, let's say I will call it uh, clock. It will show us the clock speed of the laptop, let's say. So I will write anything here, let's say 3 4 5 6 7 8 9. Right. So if I just go here and I will create an object for this class, I can write computer. Now if I will call my object c1 and I will put dot here, you can see this clock is present in the list, but we also have two other methods. We have this company and this specs method also here, right? So that means this computer object or c1 object is inheriting all the methods that were present in this brand class. I will simply go here and I will uh, change these spellings, and I will come here, and here you can see all the methods from the computer class and the brand class are listed here. So let's say I mean I call this sorry, I call this clock method, and I will save this program and I will run this program. So you can see this clock speed is printed out because simply we called our c1. or clock from a C1, right? I'll just go ahead and comment this out. But what if I will comment this out also. What if I want to call my company method from C1? Let's call it. And from C1, I will call my company. And you can see this company method clearly belongs to this brand class. But I'm calling it from C1, and C1 is the object of computer class. I will just save this program and I will run this program. And you can see the del has been printed out, right? That means this C1 has this company method. And how, I mean, this company method is written inside this brand, then how C1 has it? With the help of inheritance. Now, this is called single level inheritance. You can call it single level inheritance. And we can call it superclass, or you can call it parent class, and you can call this subclass or child class, right? Now, why do we call it single level inheritance? Because this computer class is only inheriting all the methods from this brand class, right? So this is a single level inheritance. But what if I create another class? Let's call it technology. Now, this technology class should have information about computers, right? Let's say. So what we do is inside of this parenthesis, we write computer. Now, if you see closely, this technology class is inheriting everything that is inside this computer. So inside this computer, we have this method and all the methods of brand. So at first, we are inheriting brand in computer class. And after that, everything that is present inside this computer, including clock plus methods of brand, we are inheriting all of that inside of this technology class. Right, so we are creating different levels of inheritance. So this is called multi-level inheritance. Let's just go ahead and create a method here. Let's simply call it test method, right? And we can print here, I am third class, right? And I will simply go ahead and create an object for it. It will be technology. Now if I just go ahead and write t1 dot, you can see all the methods in this list. I mean, you have the company and specs from the brand. This clock is from computer class, and this test is from this technology class that we just created. So if I just go ahead and let's say click on this clock, and I will save this program and I will run this program, you can see the clock speed has been printed out, right? And this clock was present inside this computer, right? So without writing all the methods of computer inside technology, we simply what we did is we inherited this computer class to this technology, and this way we are using its method inside technology class. What if I just go ahead and simply call company here, and I will just go ahead and write. And here you can see this del has been printed out because this company was inherited from brand to this technology uh, through computer, right? So this is called multi-level multi-level inheritance. But we also have another type of inheritance. We can call it multiple inheritance. Now what is that? If you, I mean, see closely, what we are doing is first we are inheriting it into this, and then we are inheriting it into this. So this is called multi-level inheritance. But if we talk about multiple inheritance, then what we can do is simply, I will remove this. Now we have two separate classes. The one is brand and the second is computer. And what we can do is we can simply call both of them here. Just by doing that, we are inheriting all these classes into this technology. right? If you just go ahead and simply remove it and put dot here, you can still see all the methods of the previous classes as well. But the method with which we have inherited previous classes is called multiple inheritance, because now we are not inheriting something from another class like previous. We are just simply calling the separate classes into another class. So this is called multiple inheritance, right? So there's a difference between multiple inheritance and multi-level inheritance. So I hope you have learned a lot from this video about inheritance, and I hope this video was informative for you. So that's it for this video. Hello everyone, welcome back to this object-oriented programming with Python series. And in this video, we are going to learn about method resolution order, and uh, another thing that we can say is called constructor and inheritance. We will see that how this constructor in inheritance actually works. So this is the basic structure that we followed in the previous video. These are the three classes. This is a brand class, and this is a computer class, and these are two separate classes. And in technology class, we are inheriting both of these classes, and we'll see that how instructor actually works in the inheritance. So what I will do, first of all, I'll just go ahead and create a constructor here. I can write init self, uh, sorry, self, and here I can print this is tech init, just to show that which instructor will work when we call any class. So the same, I'll just go ahead and copy this constructor from here, and I will write it here, but this time obviously I will write computer in it, and the same will go for the brand, but this time obviously I will write it brand. So first of all, what we can do is we can simply I'll remove this inheritance, and we can simply create the objects, and we can see that how these constructors actually work. So for brand, I will create b1, and here I have a brand, and I can save this file, and I will run this program, and you can see the init or the constructor of the brand class has it printed out, right? And same will go for computer class, and same will go for technology class, right? We can just simply run this program, and here you can see for b1 brand init, for c1 computer init, and for t1 tech init, right? So that's how inherit this init work in simple classes, right? So for example, we have let's say these two separate classes, but in the third class, I want to inherit everything that is present in computer, and then everything that is present in brand, right? So now what we will see that what actually happens if I will run this program. Here you can see I will simply just remove this, and I will simply call my T1 object from technology, and I will run this program again. And here you can see the tech has been printed out, right? I mean, obviously, we are calling the object from technology, so it will go into technology class. And if this class has any init function in it, then obviously it is going to call that init function, right? But what if we don't have any init inside it? What we have is just a function test self, and inside this test we have print this is test. Now our technology method doesn't have any kind of constructor in it. I will save this program, and now we will see that what actually happens, which init function or T1 object will call. I will just run this program, and here you can see we have this computer init. So that means this computer init method has been, or the constructor has been called by this T1 object, right? So that's how constructors actually work in inheritance. But here's a question: that why, I mean, why did it go to this computer class? Why it only called the constructor of computer? Why not call the constructor of brand? So here comes a concept of method resolution order, or we can also call it MRO. So whenever we have this inheritance structure, when you will inheritance your classes to your another class, then the class that is present on the left hand side will be called first, right? So that's how that is the reason that why computer init has been printed out, right? So now, this was when we have no constructor in our this subclass, which is called technology, right? But what if we have a constructor inside of our this class? I mean, this technology class. What if we have constructor in it? And what will happen then? Then which constructor will be called first? And what if we call, if we want to call the constructor of the superclass? Then how we can call that? So I'll just save this program and I will run it. And here you can see, because this time we have init in technology, then that is why this init has been printed out, right? But what if we want to, I mean, call the constructor of either of these superclasses, right? Now we have two superclasses, right? I mean, we have a brand superclass, and then we have a computer superclass, and we are inheriting both of these classes into this subclass technology. What if I want to call a constructor from either of these classes? So all I have to do is, inside of this constructor, I will call my super. So super is a keyword that actually tells us that we are going to inherit the constructor from the superclass. So I will just call this superclass, and I will uh, enter point, and here you can see we have a couple of different uh, attributes here, and here you can see we have init. Just go here and this. Now if you just save this program, now here you have to see that first your technologies constructor has been called, and because in that constructor we have the constructor of a superclass, then that super constructor has also been called, right? So this is the output of the computer's constructor, and this is the output of your technologies constructor. But again, why did it go to computer class? Why not brand? Then again, we have the concept of method resolution order here, MRO, that whenever you will have multiple classes, multiple superclasses, then the one that is on the most left hand side will be called first, right? So left to right is the way that we have to remember. So what if we I mean, we want to call the constructor of brand? Then what we have to do, you can simply just go here and you can call your brand here, right? So probably you won't don't have to write this in it, but let's just try. Right, so it's just giving us two outputs, because we are calling init by this and again init by this. So you can just simply go ahead and remove this and save it, and here you go. Now your brand constructor is being called, and your tag instructor is being called. So that is how constructors work in the inheritance And now we also know that what is method resolution order, or MRO. So that is it for this video. I hope that you have learned a lot from this video. Thank you. Hello everyone, welcome back to this object-oriented programming with Python series. And in this video, we are going to discuss another very important topic of OOP, which is called polymorphism. So the polymorphism, from the word itself, if we break this word, then poly means many and morphism indicates different forms. So it means that we will have the objects that will have many forms. We will create objects that will have different forms, different shapes or names, but they will behave exactly the same way. So there are four different methods with which we can perform this polymorphism, and one of them is called duck typing, which is we are going to discuss today. So here, duck means obviously duck, and typing means its type. Here's a very popular saying that if a bird walks like a duck, talks like a duck, quacks like a duck, swims like a duck, then it's a duck. So, for example, if I'll just create a class, let's say it's a class 1, and then I will create a class 2. So, if both of these classes will have methods that will behave exactly the same way, then I can say that this class is exactly like this class, or this class is exactly like this class. So, even though these classes or their objects will have different forms, I mean, it will be called one, or it will be called two. But if we change their names, then even after that, these classes will work exactly the same way. So what I'm trying to say is, I'll just go ahead and I will write a very simple code, and we will try to understand that what is polymorphism and what is duck typing actually. So let's say I will create a laptop class, because we were talking about computers and laptops in all of our previous videos. So let's create a method in it called specs. And in this method, let's say I put the specifications of i5, 512 GB and 16 GB. So i5 is the core processor CPU, and 512 GB is the hard disk, and 16 GB is the RAM, right? So what I will do, I'll just go ahead and I will create another class, but this time I will create a class called mobile. But what I will do in this different class, I will create the same method called specs, and I will write self in it. And this time I will change my specifications. Let's say a mobile have a Snapdragon CPU. It has 128 GB of space and 8 GB of RAM. Now what I will do, I'll just go ahead and create a polymorph named class, and in this class I will create a method called test. And in this test method I will say self, but additionally I will also take an object that on which we will work. Now what I will do, in the body of this method I will write object dot specs. Now these specs can either be this specs, or it can be this specs, right? Based on the objects that we will give to it. So what I will do, I will just quickly go ahead and create the objects for all three classes. I will say L1 is for laptop, and M1 is for mobile, and P1 is equal to polymorph, right? So what I will do, I will simply just go ahead and I will call my P1, and from this P1 I will call my test method, and in this test method I have to give an object, remember. So I will just simply go ahead and give this method M1 here. So I will just go ahead and run this program. I will say this. Oh, I just made a little mistake here. I had to put equals there. So I'll just quickly clear this terminal and I will run this program. So here you can see, because I gave M1 object to this test method, that's why the specifications of mobile devices has been printed out. Here you can see. But what if I just go ahead and let's say I will change it to L1. But this time I have the specifications of a laptop, right? So that's what polymorphism is. If you take a look quickly, all I did was changing M1 to L1, and this program did not return any kind of error. And what was the reason? The reason was that both of these classes, both of these objects, had this specs method in them. So in a sense, this class mobile, because it has same method as this laptop class, this mobile class is behaving exactly like this laptop class, right? So I will say that if this class quacks like laptop class, then it can also be behaved, or it has the same type as a laptop class. So that's what polymorphism is, and that's what duck typing is. I hope this video was informative for you, and you learned that what is duck typing and how we can perform that in our Python inside our object-oriented programming. In the next videos, we will learn that what is operator overloading and method overloading and method overriding. Hello everyone, welcome to this object-oriented programming with Python series, and we are discussing polymorphism, and we are discussing the four different methods that we can or that are associated with this polymorphism. Today we will discuss what is operator overloading and how we can use it in Python. We will start right from very basic examples, and then we'll take it to the objects and classes. So suppose that we have two variables. The first one is a, and the second one is b. And in a, let's say I will just go ahead and store a value of 5, and in b I will store the value of 10. Now this 5 and this 10, they are integers, right? And because of them, the type of this a and b, this is also integer. Now what happens when I will just go ahead and I will print out a plus b? Now, first of all, we have to understand that what is this expression actually. Here, a and b, both of them are operands, and this plus here is called operator. And whenever we will use these operators in Python, these operators actually mean something, and that meaning has been defined at the backend by the creator of this Python programming, right? So in this case, we have the data type of this a as integer and the data type of b as integer as well. And this expression shows that we are adding two integers. When we talk about integers or strings or float or something like that, we are actually talking about classes, because these are classes. If you just go ahead and write int here, and after that you just press dot, here you can see these are all the methods that are present inside this int class, right? For example, we have this float, we have floor, flags, gt is greater than, and exactly, I mean, similarly we have other sorts of methods like round and r power and etc. So whenever we talk about integers and then we use plus here, then this plus actually means that, okay, go to this class integer, and from this class call add method, right? So this plus operator is defined to call this add method from this integer class when both of these variables are integers, right? And after this calling this method, all we have to do is give it two variables a and b. I will just simply go ahead and comment this line, and I will save this program and I will run this program here. And the answer of a plus b is 15. Now if I just go ahead and comment this out and uncomment this, and I will just print the result of this, we will see that the output of this line is exactly the same as the above line. Here you can see it also yields 15. So that means whenever we use integers and then we use plus operator in between them, then what we actually are doing is from that integer class we are calling add function. Similarly, if we just go ahead and write minus here, then we will not call add, we will actually call sub function, and the answer will be exactly the same. Now, all of this has been defined by the creator of Python at the back end, right? So let's say if I just go ahead and change the type of my variable, I will first it was integers, and let's say I convert it into strings. Now I will just go ahead and write add here, but this time because we have both of the variables as strings, of course we will not go to the class string, we will go to the class str, right? Now, when we will use plus inside it, and let's say I will just comment this line out, and I will uncomment this, and I will save this program, and I will run this. Hey, here you can see this time this plus didn't mean that it had to add all of these variables. Instead, this plus meant to concatenate them, right? And how did we know that we have to concatenate? Because we are dealing with the strings this time, right? So instead of adding, it just concatenated 5 and 10. And if we just uncomment this and comment this and run this program, here you can see again 510 has been printed out, and the both of the variables have been concatenated to each other instead of being added. So I mean it has same methods, but because this time we are using string, then the meaning of this plus has been changed. Now this meaning has been defined at the back end, right? To all the classes that are built-in classes like integers and strings and float and whatnot, right? But as soon as let's say, I mean, I hope until now it's clear. But what if let's say I create my own class? I mean, this is not a built-in class. This is something I have created. Let's say it's a student class, and in this class I will create a constructor, and in this constructor I want two variables, m1 and m2, and I will say self dot m1 is equal to m1, and self dot m2 is equal to m2, right? So what I want is I want to create the object s1 from the student, and I want to take two numbers and I want to add it. Let's say I have created this object here, and then I have created another object here, let's say, and this time I would say 50 plus 30. That's it. Now, what if I want to add both of these? I will say s1 plus s2 should be equal to s3. I will just save this program and I will run this. Now here you can see we have an error which is called type error. But what is the error? We have unspotted operand types for plus student and student. That means we don't know, or our program doesn't know that what is the type of these s1 and s2, and what is the purpose of this plus, because this time this class is not built in. We have to define the meaning of this plus, right? So what if I just go ahead and write a method here? I will say def add, just like in integer and string, and this time I will use two variables. First one I can call self, and let's call the other one as other. Now what I can do is I can say m1 is equal to self dot m1 plus self dot m2, and m2 is equal to self dot we we use self other dot m1 plus other dot m2. What if And after that, let's just take S3 and M1 plus M2. And after that, just return your S3, right? So now if I just go ahead and I will try to print my S3, we'll see that what happens. I'll just run this program. Okay, you can see this time it actually added all these values, right? And this time it didn't give us any kind of I would say error saying that this operand or operator is unsupported, because this time we actually what we did is we defined our plus inside of our class, that okay, whenever we will call this plus operator, our method will do all of this. So we have defined our variable. So this is called operator overloading. You can define it as as you like. I mean, instead of, let's say, uh, adding them, you could write subtract them, for example, right? You could say this. And if we just save this program, and now whenever you will call plus, so this time instead of adding everything, it will subtract everything. So in your class you have defined your operator. So this is called operator overloading, right? I'll just simply go ahead and add or replace all the minus with the plus again. And this time what I want to do is I want to create another method. Let's say if I just comment this out, what if I want to compare both of my objects? I can say s1 is greater than s2. If that's true, then print uh, s1, let's say. Otherwise, else, just go ahead and print uh, s2. Okay, if I just go ahead and I will run this program, here you can see again it gave me a type error. It said that this operator is not supported because I did not define this in my student class. If you were talking about integers or floats or string and whatnot, uh, in that case, because at the back end the creator has defined this operator, this greater than operator, for integers or float, then in that case it will not give any kind of error. I mean, just like here. But in our case, we have created a new class and we haven't defined this operator here. That's why it's giving us this error. So what I will do, I'll just quickly go ahead and create another method called gt. So gt means greater than, and here what I will do, I will simply call two variables. We can call self, and this other one we can just simply call other. Now what I will do, I mean, we have to define this operator here, because when we so when we used this operator for integer or for float or something, then at the back end, the creator of Python has defined the meaning of this integer or this operator. But in our case, we are creating a new class here. So in order for this operator to work in for our class, we have to define the meaning of it inside our class, right? So what I can do is we can create a variable called n1, and here you can say self dot m1 plus self dot m2, and here you can create another variable called self dot other dot m1 plus other dot m2, right? And after that, here we can say n2. So after that, we will use if operator. We can say if n1 is greater than n2, then return true. Otherwise, just go ahead and return false. So if n1 is greater than n2, then it will be true, and as a result, S1 will be printed out. I'll just simply go ahead and reduce these spaces, and in case the result will be false, then S2 will be printed out. Let's just simply save this program, and now if we will just return this program, here you can see this time this operator did not return any kind of error because now we have defined it. But the question is, I mean, this operator didn't work for S1 and S2 because these were objects. But why this operator worked here? Because here N1 and N2, they are the numbers, they are the values that are stored in the objects. And here they are simply the objects. But when we define this operator for the values of these objects, now as a result, this operator will also work for these objects, right? So here we can see 50 plus 13 is 63, sorry, and 45 plus 6 is 51. And because S2 is greater, that means S2 will be printed out. And here you can see S2 has been printed out. So that's how you can define your operators for your custom classes. And this is called operator overloading. And that is related to polymorphism. So I hope you have learned a lot from this video, and I hope that in the next videos you will get familiar with method overloading and method overriding that are also related to polymorphism. Goodbye. Hello everyone, welcome back to this object-oriented programming with Python series, and we are discussing polymorphism. Today we will discuss method overloading. So first of all, we will discuss that what is method overloading, and then we can discuss that if we can apply it in Python or not. So in simple words, for example, I have a class student. In that class, if I want to create a method, let's say I will create a progress method. I will say self, and I can write print in it. This is first method, and after that I want to create another method such that this method also contains the same name as the previous one, even though your attributes are different and your body is different. This is a second method. Even though that's the case, uh, both of these methods will have same name. So this is called method overloading. But in Python, we cannot create two methods with same name, even though giving them a different amount of attributes or different bodies. We just can't create two methods with same name. So that's why in Python we don't have method overloading. So for example, if I want to create two methods, so in method overloading, let's say my first method will have two variables, and the second method will have three variables, right? So that's what method overloading is, right? But as we don't have method overloading in Python, but we still have a couple of different tricks that we can use to get around this. For example, in student class, I want to create a method called total marks. That's it. Now, in this total marks, I will say self, and uh, I will have two or three attributes here. I will say math, physics, and chemistry, for example. Now, what I want to do is I want to add all three of these subjects and give a total. Let's say I will have total is equal to math plus physics plus chemistry. And as a result, what I want to do is I want to return the value of total. Right? So until now, it's pretty simple. We have created a class, we have created a method. It contains three attributes, and as a result, it adds all of them and give us the value. What I want to do is I want to create an object, and we can call it student. And S1, from S1, I will call total marks, and in this method I will give my numbers. Let's say maths is 45, physics is 50, and chemistry is 40. That's it. And I will print this out. So run this program. You can see all three numbers have been added. But what if instead of three arguments, I give only two arguments? If I save this program and I will run this program, here you can see it's telling me that you are missing one uh, positional argument for chemistry, because in my method I was accepting three attributes or three arguments, but here I am giving only two. So if we had method overloading, then we could create another method called total marks, and in that method we could only take two variables, right? But since we don't have method overloading in Python, so we have to come up with a different technique to do that. So we can there are multiple ways that we can do it. We can use the steric based multiple attribute system, or we could also give initial values such as none to all of these three attributes. So if we just write none, so initially all these three attributes have the value of none. So in this case, if I only give two values to this method, if I save this program and I run it. Okay, sorry, we had to create the body. If I just go ahead and write here, if math is not equal to none and physics, sorry, physics is not equal to none, that means we have values for them, and chemistry is not equals to none, then do this, then add all of them. Else if we can create another method, we can simply just copy it, and we can say else if math is not none and physics is not none. In this case we are giving two values, right? So what you want to do is total is equal to math plus physics, and the third condition is elif math is not none. That means you are giving only one value, and in this case, total will be equals to math, because we don't have anything else to add in this math. And the result we will return our total. If I just simply save this program and run this program here you can see, because I gave two numbers only, 45 plus 50, our method has added them, and the result is 95. And we don't even though our method takes three arguments, we gave only two, and even after that our program ran pretty nice, right, without any error. I can again run this program, and you can see we have the answer of 95. So that's something that we can utilize to perform method overloading in Python. But the truth is, when it comes to Python, we don't have method overloading. It is present in Java, in C Sharp, or other programming languages, but it doesn't exist in Python programming. In the next video, we will discuss that what is a method overriding. It's pretty simple. So good luck for the next video. Hello everyone, welcome back to this object-oriented programming with Python series, and we are discussing polymorphism. And today we are going to discuss the last method to perform polymorphism, and that is called method overriding. Now, what is method overriding? First of all, we have to understand that what does it mean. So, for example, just like its name, we have method, which is a function inside a class, and we have overriding. So basically, what we are doing is we are overriding methods with another method. So just like method overloading, here we will also have two methods with same name, but obviously just like we discussed in our previous video, It's not possible in Python to have two methods with same name inside a single class. So here we will discuss the concept of inheritance, and then we will try to perform method overriding in it. So for example, I have a simple class. I can say laptop, because since the beginning we are talking about laptops and computers, uh, and I want to create a function called the specs in it, for example. Now in this specs I will call self, and here I will print, let's say, i5 512 GB, just like earlier, and then I will have 16 GB in it. Now here, what I can do is I can create another class and I can call it, let's say, computer class. And for the time being, I will write nothing in it, or let's say I will create a method, and in this method I can say CPU, or I can say GPU. I can say self, and here I will write print. I can say NVIDIA GPU. Right. So if I just go ahead and create an object for laptop, I can say laptop. So I can simply call L1 dot specs in it, and I can run my program, and it will run completely fine. Right? It will print out all the specifications of my laptop. But what if I just go ahead and instead of first of all, I will just create C1 for computer. And what if I just go ahead and replace this L1 with C1? And if I save this program and I will run this program, right? So it's telling me that you don't have any attribute called specs in your computer class. I mean, you are trying to call this specs method from your C1 object, and C1 object is from computer, and inside computer you don't have any specs. So here we will use the concept of inheritance. Let's say I will have a laptop written inside it. Now, if I just save this and run this program, here you can see now it didn't show me any error. Instead, it gave me all the specifications of my laptop, because now I inherited my laptop to my computer. That means everything that my laptop had now is present in computer. So this is something that we have discussed already. But what we want to discuss now is what is method overriding. So here you have to pay attention to my words, and you have to listen to very carefully here. When we called our object computer, and from this object computer we called specs, first of all, what your code does is it looks for this specs in your computer class. But because we don't have any kind of specs method in this computer class, then it goes to its parent class and looks there, and it finds there, and then it prints out all the output or all the body that has been written inside that specs. But what if I keep everything like this, and I just add a method called specs here, and it will be self, and here I will write this specs is in computer class. What happens now? What if I run this program? Now, what will happen? You can see instead of going to the specs of your laptop class, this time your C1 printed out its own specs, because now it has its own specs method. So I mentioned it earlier. When you run this program, your objects first of all looks inside it for the method that you have called. Before, we didn't have this specs method in computer class. That's why it went to the parent class and looked there. But now it has its own specs method. So that means now it doesn't have to go to its parent class. That's why it will ignore the laptop specs method, and it will print out or execute the specs of computer class. So this is called method overriding. And it's very important concept that you have to understand, because it's quite extensively pursued in software industry or in interviews and stuff. So that's it about method overriding and its relevance or its association with polymorphism. I hope you have learned a lot from this series, and I hope that it was beneficial for you.